evening, dear participants. Once again, welcome you all for the session one on day one on the topic opportunities and challenges in artificial intelligence and machine learning for mechanical engineers. Today we have with us the resource person, Sri Avinash Khare. So now I am going to read out the profile of Sri Avinash Khare, sir. Sri Avinash Khare obtained his BE in Electrical Engineering from Maulana Azad National Institute of Technology in the year 1982. He worked at Tata Motors Limited for 33 years from 1982 to 2015. During his tenure there, he worked in functions of product design and development in industrial electronics. He served as the head of machine shop and maintenance for production engineering division, which makes test tools, sheet metal, and machining fixtures, gauges, and foundry tooling for automotive production. The positions involved during his tenure were ensuring performance of stock on SQD, CME, balance scorecard, template, cost and budget control, HR, IR coordination, selection, procurement, installation and maintenance of capital equipment and shop facilities. He was head for Technology Center for Metal Forming, IMTMA from 2015 to 2021. Currently, he is self-employed as a consultant and corporate new manufacturing technology and automation. Now, with this, I warmly welcome Sri Avinash Khare sir to take this session.
Thank you.
Thank you, sir.
Thank you. Ladies and gentlemen, welcome to this first session of this course. Am I loud and clear? Is my voice clear?
Yes, sir. You are audible, sir.
Okay.
Yes, sir.
So, without much ado, I will share my screen. Let me. Ladies and gentlemen, are you able to see my slide?
Yes, sir. No, slides are.
Hello. Slide is visible?
No. Yes, sir.
Not visible?
Yes, sir.
So you are able to see my slide?
Yes, sir.
And I believe you are able to hear me as well.
Yes, sir.
Fine. So, welcome once again, ladies and gentlemen. I am starting this session. What I intend to cover in these 90 minutes is as follows. First of all, we'll start with what is AI, a brief introduction on AI. Then, how does AI/ML work? Then we'll talk about application of AI/ML for adaptive auto tuning of servo-controlled motion systems. This is one of the application. Then we can talk about application of AI/ML for adaptive machining parameter optimization and control of chatter marks while machining. Of course, in between we can have application of AI/ML to ensure dynamic precision of large size machines. Okay. Then we'll have a topic on monitoring of welding and post inspection of welds using AI/ML, and of course AI/ML for vision system based inspection of assemblies. So that's the agenda for this session for these 90 minutes. If there is any difficulty in my reaching you, please do highlight to me so that I can make some amends. And if somebody want to ask any question, you are free to ask, of course, anytime. Okay. So some disclaimers before we start. Nowadays, generally, when people say technology, more often than not, they mean information technology. In this session, when we say technology, it means core technology, mechanical engineering. So this is first disclaimer that whenever I say technology, it means mechanical engineering, not IT. Okay. Secondly, when IT professionals or academicians say the word artificial intelligence, actually they are referring to use of certain jargon and or certain software features which are in vogue in their parlance and publications. So I'm not going by that. I will define what we mean by artificial intelligence during this. Okay. Usually courses in AI, they include, basically they end up teaching Python and sometimes teaching use of Hadoop, Arduino. Now these are only the softwares which are in vogue, but by no means learning these software means you know AI. Artificial intelligence is beyond these software tools. Okay. So actually these are tools and they have nothing to do with AI per se, AI or ML. Okay. Generally, when IT people say machine learning, they are not referring to machine tools, but they are referring to computers learning. Now, in this course, when I say machine learning, we mean actual machine learning. Okay, fine. Now, even before I start, we have uh, had some dispute about what is the definition of artificial intelligence. Now, traditionally, machines trying to emulate a human brain is said to be artificial intelligence. Means if your machine or computer is able to think like a human being, you say it is artificial intelligence. But I will have objection against this definition because that is natural intelligence. How brain works is natural intelligence. So if a computer is simulating natural intelligence, how does it become artificial? Right? Now, according to me, of course, you can differ with my definition. Artificial intelligence ought to mean intelligence based on artificial senses, which means that suppose, okay, in our natural senses, we don't have infrared. We cannot see what X ray can see. But nowadays, we have the machines which can see infrared, which can see X ray, see through X-ray. So whatever we learned with these additional senses is, according to me, artificial intelligence. But okay, for today's session, we'll not take that definition. We'll go by the conventional definition, whatever is understood by AI in that parlance. Okay. Now, let us say what is artificial intelligence. As I said before, programs with the ability to learn and reason like human being. That is what traditionally we have been terming as artificial intelligence. Now, machine learning is a subset of artificial intelligence where we talk of algorithms with the ability to make the machine learn without explicitly programming it. Otherwise, a robot or a CNC could be programmed. But as long as we are able to make them learn without programming, we can call it machine learning. But machine learning, of course, is a subset of artificial intelligence. Artificial intelligence is much bigger umbrella under which you have some things like a chess playing computer, maybe, which has nothing to do with machine tools or manufacturing or mechanical engineering per se. Right? So, machine learning is more closer to our world. Then within machine learning, there is something called as deep learning, which is a subset again of machine learning, where we use neural networks. Now, brain is made up of neurons. Similarly, we have some notion that we have neural look-alike uh, emulation in computer. Okay, so that is what we call as deep learning through neural network. Okay, CNN we call it, convolutional neural network, etc. Things like that. That we will see more of it as we go further. Now, this is what I was saying, that how this is AI. It is natural intelligence. It is emulation of natural intelligence. But okay, since we have been calling it that way, is fine. Now, this is basically an extension of automation for predictive and adaptive machine and industry controls. Okay. Now, if we have to improve the situation that is existing, anything that we do must do some improvement somewhere. Now, this improvement can be done through two ways. One is through technoastrology or through simulation or through prediction or through adaptive controls, real time adaptive controls. Okay. Now, machine learning is interfacing with both of these kind of improvements. It's a kind of automation for carrying out improvements through predictive learning or adaptive learning or adaptive control, so to say. Right? And deep learning is used to make the machine deal with the vagaries of human behavior. Now,
ladies and gentlemen, you must have heard a lot about Industry 4. In the inaugural speech, I could make out some mention of Industry 4. Now, beyond Industry 4, there is Industry 5, which is looming large on the horizon. And Industry 5 is not extension of Industry 4. It is, in fact, in a way, quite opposite to Industry 4. In the sense that Industry 4 advocates total automation, and Industry 5 advocates human touch into everything. Because there is a belief that all the premium products have to have human ingenuity, human creativity, human adaptivity, human dexterity, and so on. You consider any premium products. Would you like to go to a restaurant where you are told that robo is a chef? Okay. And machines and products made through complete automation would look like maybe glucose biscuit. Of course, I have nothing against that particular brand. But then all the biscuits are absolutely identical, but they are low cost. They are meant for masses. But premium biscuits are handmade butter cookies still. You see any premium products, there is a touch of human ingenuity in it. Whether it is premium wines, premium cakes, premium eatables, premium cloth, premium embroidery, premium silk, Banarsi saris, or whatever you say. All the premium products have to have human touch. So now we are coming to an era where we have to have automation, but we have to have human touch. Which means that we have to have robots which can work like a co-worker with a human operator, because both will be there in the process, right? So up and so far we have learned to adapt to the machine. We have been learning G code programming to run the CNC machine. We have been learning how to teach into the robo, but we are adapting ourselves to the way the robo works. Correct? Now, in the coming era, we are talking of machines adapting to human. Now, how do you like it? Industry 5 is advocating precisely that. That human will not adapt to machines, machines have to adapt to human. Which means that machines must understand the variability in human behavior, human expression, and so on. So, suppose you have a robo uh, which can decipher the spoken words by a human operator. Okay. Now, with artificial intelligence, we want that robot to be able to understand his co-worker. Now, if his co-worker is from south, for example, and sometimes operator is not supposed to give a command in a cryptic code or through remote. Suppose in working, the robot just hires IIO or Lahore Vilakkuvat, depending on who the operator is. The robo has to make out why this was said and what he is supposed to do, what the robo is supposed to do against it. Okay. So the variability of human expression, the variability of human handwritten text, the variability of human gestures and voice have to be understood by machines. Now that is the era to come. Now, if that has to happen, then we have to have some kind of deep learning into the robots, into the machines, so that they are able to decipher the human behavior, the precise meaning of why something was said in some context. Okay. I hope I am clear. If there are any questions, please do ask. Okay. Now, this is what I have already spoken so far. Now, in order to save time, I am making help of some videos to communicate what I want to communicate very fast. Okay. So, to cut down on expression. So, let us say what is machine learning very briefly through a short video. I hope you are able to hear the sound. If not, please do let me know. Even I am not able to hear. But sorry, I'll share it once again.
Sir, voice is not coming, sir. Hello?
Can somebody help me to share the sound of the system?
Sir, pardon, sir. Avinash Khare, sir.
Yeah, I hope you are able to see the screen all right.
Yes, sir.
Sir.
Fine. Okay, it is text is coming anyway.
Sir, can you remove the headphones? I think then the system voice may.
Now, suppose you want to know whether Paul will like a song or will not like a song. And Paul generally likes a song if they are having high tempo, okay, and high intensity. So, Paul is liking a high tempo music and high intensity music. Now, suppose we just have a 2 by 2 matrix where we plot, let us say, intensity, tempo on x axis. So Paul is known to like something which falls somewhere here. Okay. So soaring music and which is fast music. Okay. And he doesn't like something which is light and relaxed. Fine. Now, so far, if you have any song and if you are able to place, you will know predict whether Paul will like or not. Right? Like if you have a song which sits somewhere here, you can predict that Paul is going to like it. Right? But suppose you have something in between. Okay. Suppose if they are not falling in this set as well as in this set, okay, if it is something here, then will Paul like it or not? So the kind of algorithms which machine learning uses, one of the algorithms is described here, that is called as nearest neighbor. Okay. So we draw a circle with certain radius around this point. Okay. Let us say we draw a circle of certain radius so that it has certain number of dots from either side. And now you just count the votes. So here there are 4 votes, here there is just one. So chances are that Paul is going to like something which is lying here. So that's how you take decisions when the decisions are ambiguous through machine learning. Now, machine learning happens in 3 ways: supervised learning, unsupervised learning, and feedback based learning. Okay, reinforcement learning. Now, suppose you have various currency, let us say 1 euro, 1 dirham, and 1 rupee coin. Okay. Now you know that this weighs 3 gram. Okay, 1 euro weighs 7 gram, and 1 dirham weighs something like 4 grams. Now, if your machine is put various coins, everything is unity. Okay. Now the machine will learn that if it is 3 gram, it must be rupees. Okay. So this is kind of supervised learning where all the data has some label. Okay. And the currency and denomination is the label. Right. Now this is called as labeled data based learning. Therefore, it is called as supervised learning. Unsupervised learning is the previous example, which where we talked about the Paul, where songs do not carry any label, but we cluster them. Okay. So we form some clusters, and based on clusters, we find out with some algorithms whether he is going to like or not. So this is the same example that I gave you earlier. So there are 2 clusters, a cluster here, and something in between. By relative distance between the clusters, we are able to figure out that what is the probability of it being liked or disliked. Right? Now this is what is called as unsupervised learning because data itself does not carry any label. There is no denomination. There is no label with the data per se. Right? And the third one is the reinforcement based learning. Suppose a child has to be taught to recognize between a cat and a dog, or a computer has to be taught to recognize the picture from the picture whether it is a cat and dog. But you have various size, shapes, and colors of cat as well as dog, and you could take the picture from any angle. Right? So dogs can look very different and cats can look very different. So the thing is, you make them identify, they will do some guesswork and identify something, and if they are wrong, you correct them.
So gradually the
Okay,
system will
so
learn
gradually the
that yes,
system
okay,
will
dog
learn
can look
that
like this
yes,
or it
okay,
can look
dog
like
can
this
look
or it
like
can
this,
look
or
like
it can look like this,
this. So
or it
after
can look like
sufficient
that.
data
So
input,
after sufficient data
the
input,
system will learn
okay,
how to
the system
distinguish
will
between
learn
a
how
cat and
to
dog,
distinguish between
and
a
it will
cat
be
and
able
dog,
to identify
and
any
it
cat
will
or
be
any
able to
dog seen from
identify
any
any
angle.
cat or any dog seen from any angle,
Now this
right?
is called as reinforcement
Now
based
this is
learning.
called as
So
reinforcement based
basically,
learning. So
these are
basically,
the three mechanisms of
these are the three
learning
mechanisms of
in
learning
machine learning.
in
So
machine
we are not
learning.
talking so much of AI
So we
because
are
we are
not
not
talking
talking
so
about
much
chess
of
playing
AI because we are
computers
not
and things
talking
like
about
that.
chess playing
We are
computer and things
down to
like
earth.
that. We are down to earth.
We are talking about machine learning.
We are
So
talking about
machines
machine
can
learning.
learn
So
either through
machines can
supervised
learn
data
either through
or through
supervised
unsupervised
data
data
or through
or through
unsupervised
feedback.
data
That is
or
reinforcement.
through feedback, that is reinforcement.
Further,
Okay.
we can talk
Further,
about what
we
is
can talk
neural
about
learning
what
or
is
deep
neural
learning.
learning
Okay.
or deep learning.
So
Okay.
we'll
So
talk about that.
we'll talk about that.
If you see the full
If you
landscape
see
of
the
AI
full
ML,
landscape of
now
AI ML,
artificial
okay.
intelligence is a
Now
bigger
artificial
set
intelligence
you
is a
can
bigger
see out there.
set you
Machine
can see
learning
out
is
there.
a subset.
Machine
We have
learning
seen
is a
that.
subset. We
Within
have
machine
seen that.
learning, we have three
Within machine learning, we have three
things that we have discussed.
things that
Supervised
we have
learning,
discussed.
this particular
Supervised
ellipse.
learning, this particular
Unsupervised
ellipse.
learning, this particular ellipse,
Unsupervised
and
learning, this
reinforcement
particular
learning, this
ellipse,
particular
and
ellipse.
reinforcement
There
learning,
is
this
nothing
particular
common
ellipse.
between these three
There is
ellipses.
nothing common
There is
between these
no
three
intersection.
ellipses.
Okay.
There is no intersection.
Now, but
Okay. Now,
neural
but
networks could be
neural
applied
networks could be
for
applied
reinforcement learning, for
for
supervised learning,
reinforcement
or
learning,
for
for supervised
unsupervised learning.
learning, or for
And
unsupervised
so
learning.
also deep learning is
And so
also
also
deep learning comprises of
deep learning
multiple layers
comprises
of
of
neurons that we will
multiple
talk
layers of neurons
subsequently.
that we will
Okay.
talk
Now this
subsequently.
is
Okay.
deep learning
Now
and
this
neural
is
based learning.
so deep learning
Both
and neural based
can
learning
span over
both
all the three
can
kinds
span
of
over
learning
all the
that
three
happens.
kinds of learning
Nowadays
that
there is a
happens.
big hoopla about
Nowadays there is a
ChatGPT.
big
Now what
hoopla
is
about Now what is
ChatGPT? Now within this there is another
ChatGPT?
subset
Now within
which
this
is
there is
called
another
as
subset
generative
which
AI.
is called as
The AI
generative
which
AI.
can generate
The
something,
AI which
can give
can
you some
generate something, can
intelligent
give you
output.
some
For
intelligent
example,
output.
in ChatGPT you
For
ask some
example, in
question,
ChatGPT, you ask
it
some
will give you
question,
the answer, or
it
you
will
give the
give you the
answer,
answer,
it will frame a
or you
question.
give the answer, it will frame
Okay,
a question.
to which that
Okay,
answer would apply.
to which that answer
Hello,
would apply.
sir. ChatGPT
Okay,
is a
Hello,
so
sir.
linguistic kind of
ChatGPT
thing.
is
It
a
is a
linguistic
language-based
kind of
AI
thing. It was a
where
language-based
it
AI
works on question
where
answer.
it works on
Okay,
question
it will
answer.
ask one question in the
Okay,
language and
so
give
you
Hello,
you
ask
sir.
some question in
answer
the
of
language and
language
give you
by
answer in
searching
some
lot
language
of data which
by
is there
searching
with
lot of data
processing
which
through
is
AI,
there with processing
through
through
deep
AI,
learning, through neural network,
through deep
etc.
learning, through neural
Okay,
network,
it
etc.
processes and gives you
Okay, it
the
processes
most
and gives you
intelligent reply,
the
so to
most
speak.
intelligent reply,
Though
so
it
to
has
speak.
been proven,
Though
it
it
has
has
been
Hello,
been
sir.
proven, because
it has
IIT
been
JEE
proven
exam it could not
because
crack.
IIT JEE exam it
The
could not
success
crack.
rate was only about
Okay,
15%.
the success rate was only about
ChatGPT.
15%
So it's not
in
that
ChatGPT. So
it
it's
is
not
the
that
super thing, it is
it
superior to
is the
human
super
intelligence.
thing. It is superior
And
to human
believe me,
intelligence.
whatever
And
AI ML we
believe
do,
me,
we
whatever
can never
AI
have a
ML we
machine
do,
to do,
we
let
can
us say,
never have
hero
a
diary
machine to
or
do, let us say,
crack
Shero
a
Shairi,
right
or
joke at the right
I mean,
instance.
crack a
That
right
thing doesn't
joke at the
happen,
right
not
instance.
even in
That
ChatGPT.
thing doesn't happen,
Okay.
not even through
It
ChatGPT.
requires human intelligence.
So that is
Hello,
what
sir.
requires human
Hello.
intelligence only.
Okay,
Correct.
within
Hello.
that, this
But
comes close to
okay,
that.
within that, this
ChatGPT,
comes
etc.
close to
The
that.
linguistic
Chat
models
GPT,
work
etc.
pretty close
Hello.
to that.
Linguistic models which work based on
Then
question answer.
another subset of it,
Then
okay, you don't have a
another
language model,
subset
you
of
are
it,
just
okay, you don't
arranging
have a
some
language model, you are just arranging
uh,
some
variational
uh,
attributes, some
variational
variables you are
attributes,
arranging
some
in some order, etc.
variables you are arranging
Okay.
in some order,
So those
etc.
are called as
Okay,
variational
so
autoencoders.
those are called
It
as
is
variational autoencoders.
parallel to
It
ChatGPT,
is
but not quite
parallel to
ChatGPT in
Chat
the sense that
GPT,
it's
but
not
not
chatting
quite Chat
directly.
GPT in the sense that it is not chatting
And
directly.
you can have other generative adversarial
And you can
networks
have
where
other
things like
generative
design
adversarial
or
network where
CAD
things
models can
like
be
design
generated directly.
or
It's
CAD models
not
can be generated
linguistic
directly.
model per
It's
se,
not
it is generating a
linguistic
design.
model per se, it is generating a design.
Multiple designs will apply to
Multiple
a given
designs,
situation.
multiple designs which will apply to a given situation
Right?
and
So
stuff
that
like
is
that.
the whole arena
Right.
which
So
is
that is the
relevant to
whole
mechanical
arena
engineers
which is relevant to
in machine
mechanical
learning.
engineers in
So this
machine
one is
learning.
linguistic. So this one is linguistic thing, and basically generative AI is something that makes data structure based on historical usage of data, based on historical success rate and stuff like that. And learned correlations will come under this aspect. Basically, we are generating some kind of correlational networks. Okay, what is correlated with what? So that is called as GANs. Okay. Otherwise, you can always have pre-structured correlations where the structure has been designed, pre-designed by somebody. Now, convolutional networks, we will see an example, CNN. Now, this is used for solving test data in real time. Let us say I have mentioned the problem of identifying cat and dogs. So you submit a picture through CNN, it gives you an output whether the identified animal is a cat or a dog. Okay. So this is, you give some test data and gives you the output directly. Now this is more for submitting some data and getting a report. Okay. So this is that kind of thing. And deep learning is about learning weightages. We will see more about it in subsequent slide. Now before that, I have talked about neuron so many times. Now let us see something about what neuron is. Now, neurons are the cell in our brain, okay, which look like star. It has a star kind of a shape with several dendrites radiating out and with one output. All the dendrites are input to the cell and axon is the output to the cell. And axon, the output, is having a layer of insulation. You can see this pink color. Okay, it's called a myelin sheath, which is the insulation. Okay, now neuron either fires or neuron doesn't fire. Neuron is either on or neuron is off. It's like that, binary. Okay. Now, how does it work? From various dendrites, various ionic currents flow. Okay. Various ionic currents flow towards the root of this output. Okay. Axon hillock is called. Now, at the axon hillock, if the potential crosses certain threshold, then the neuron fires and it sends a pulse down the length of axon with some propagation delay, of course, right? Like it's a transmission line, so there will be a propagation delay, right? So it sends a command or a signal to the output that yes, I have fired, and then that output is relayed to so many places. It can go back to so many neurons as a feedback, as a feed forward, or whatever you choose to call, or it can go directly to muscle to have muscle contraction, some physical action, correct? And these inputs can come from various other neurons or through senses, through touch sensors or through smell sensors or through vision sensors or whatever. So some fluid current will flow, ionic current will flow if some input is presented to this link, for example. And based on the morphology of the tree, based on the cross section of these channels, sometime under some combination, this threshold will exceed and neuron will fire. Now this is how it works. Okay. Now this is what I have said just now. Correct. So when the neuron fire, it carries the output and it is communicated to other neurons. Simple. So basically, the neural network looks like this. The output of one is connected to several inputs of several other neurons, and so on. Okay. So there, in a signal flow chain, in a logic chain, there may be layers of neurons, one after another. You can encounter several neurons in a loop. Correct. So this is how it works, and there are interconnections which carry ionic current, and if it fires, it carries action potential. Simple. Now, basically, if you try to simplify the situation, there are many inputs to the neuron. So, neuron, suppose you consider it as a black box, there are so many inputs, let us say 1 to 16 in this case, and there is a single output. Either neuron is fired or it has not fired, but the output is relayed at so many stations. So output 1, output 2, output 3, 4, 5, 6, which can go to several places depending on interconnections. Some of the output may go back as a feedback to the same neuron also. That is called as autosynapse. So this is directly talking to itself with a time delay, of course. That yes, I have fired. That feedback comes again back to the same neuron. Okay. Now this is how it works. Correct. Now what happens here is interesting. That suppose based on certain combination of inputs, the neuron is firing successfully. The ionic channels become bigger and it becomes easier for neuron to fire. And maybe earlier with 5 inputs the neuron was firing. Now later with 3 inputs also it may start firing. So the interconnection between these inputs and outputs, it goes on evolving due to learning. Okay. Now that is what
the
is called as learning.
probability of neuron
The
firing
probability of
increases
neuron
depending
firing
on the past
increases
history of success rate.
depending on the past
Now, what
history of success
combination
rate.
made it to fire?
Now, what
Okay,
combination
if
made
it
it to
comes again
fire?
and again,
Okay,
it
if
becomes
it comes
easier
again
for
and again,
neuron to
it becomes
fire,
easier for
even if
neuron
all the
to
combination is
fire,
not met
even if all
later.
the combination is not met later.
And in extreme case, maybe with just single input also
And
it may
in
start
extreme
firing.
case, maybe with just single input also it may start firing.
Whereas, based on the failure
Whereas,
rate, the probability of
based on the
firing
failure rate,
diminishes.
the probability of firing diminishes.
So there is something which is monitoring the success
So
and
there is
failure rate
something
of
which is
the
monitoring the
fire.
success and failure rate of the neuron
So if it
firing,
has not
right?
succeeded for a
So
long
if it
time,
has not
it becomes
succeeded for
more
a long
difficult
time,
for it become
it
to
becomes more difficult
succeed to
for
fire next
it
time.
becomes to succeed
Okay.
to fire next
Now
time.
this is how the
Okay.
biological learning
Now
works.
this is how the biological learning works.
Now you can approximate. Like one
Now you can
approximation
approximate.
is
Like one
here, approximation
approximation
level
is
one.
here, approximation level
That
one.
these are the various inputs, this is the
That
output.
these are the
You
various
assume that
inputs,
there
this
are
is the
some logic
output.
gates in between. I
You
suppose
assume
all of
that
you
there
know
are
what
some
are
logic
logic
gates
gates.
in between. I
And or,
suppose all of
and
you know
or.
what are logic gates.
You must have
And
done
or,
a little bit
NAND
of
or,
electronics
etc.
sometime,
You
whatever.
must have done a little bit
Right?
of electronics
So
sometime,
based on
whatever,
some
right?
combinations, the
So
output
based on
comes,
some
and some
combinations,
combinations
the
it will
output
not come.
comes, and some
Now
combinations it will
depending
not
on
come.
the success rate,
Okay.
you may
Now
change
depending
the
on the
AND
success
gate to
rate,
OR gate.
you may change the AND
So you
gate to
don't
OR
require
gate.
all the inputs with pure input
So
also
you
it
don't
will
require all the inputs
successfully
with pure
fire.
input, also it will
Right? Now that's how
successfully
learning
fire,
happens.
right?
Now there used
Now
to
that's how
be
learning
a
happens.
electronic device
Now there
called
used to
the
be
programmable array
electronic
logic,
device called as the programmable array logic
ALU
long
electronic,
back.
where you were able
In
to
80s I'm
program the
talking,
gates between input
where
and
you were
output.
able to program the
If you
gates
want to
between
program
input and
AND gate,
output.
OR gate, so in a
If you
way
want to
the
program
neuron
AND
becomes
gate,
like
OR gate,
programmable
so
array
in a
logic.
way the neuron becomes like
So you are
programmable
able
array
to
logic.
program the logic in
Okay.
between.
So you
Thereby
are
you
able
are
to
able to
program the logic
program
in
the AND
between.
in between
Thereby
inputs
you
and
are able
outputs.
to program the relation between
Now
inputs and
this is
output.
an approximation, of course.
Okay.
This
Now
is you
this
are
is an
approximating that
approximation,
all
of
the
course.
inputs are 0
This is
or
you are
1 and all the
approximating that
outputs
all
are
the
0 and 1.
inputs are 0 or 1 and all the outputs are
Then
0 and 1.
approximate.
Correct?
But then
By
here we are not considering the
approximation.
transmission
But
delay,
then
the
here we are
effect
not
of
considering the transmission delay, the
the
effect of
impedance of
you
ionic
know
channel, the
the
transmission
impedance of
delay, the
ionic channel,
propagation
the
delay. All
transmission
those things
delay,
are
the
approximated,
propagation delay. All those
simplified.
things are
In
approximated,
the real term, it don't
simplified.
look like this actually. It
In
will
the
be
real
like
terms,
an
it looks
op-amp
Hello.
something
based
like this actually. It will be
operational
like an op amp
Hello.
amplifier.
based circuit,
I believe my
operational
friend knows a
amplifier
little
based
bit
circuit.
about op-amps
I
also.
believe my friend
Hello.
knows a
So,
little bit
but
about
here we
op
are
amps
talking of
also.
analog values.
So,
So you
but
are
here
doing
we are talking of
summation and
analog values.
subtraction,
So you
and
are doing
along with
summation and
integration
subtraction,
delay,
and
ramping
along with
delay, and all
integration
those.
delay,
Some delays will be
ramping
taken care
delay, and
of,
all
some
those. So
differentiation
some
will be
delays
taken
will be
care of,
taken care of,
and
some
some
differentiation will be taken
PID
care
kind
of,
of concepts will
and
be
some
there,
PID
proportionality
kind of
derivative,
concepts will be there,
so based on
proportional
some
integrated
combinations,
derivative,
this
etc.
will
So
successfully
based on
Hello.
some
output or it will not.
combinations, this will
And
successfully
logically,
output or it
biological
will not
neuron is
output.
closer to this.
Now,
Hello.
But
actually,
when we
biological
solve it through
neuron is
computer,
closer
we
to this,
approximate it to
but
something
when we
like
solve
this.
it through
And not
computer, we
even like
approximate
this.
it with something like this, and not
Basically,
even like this.
oversimplified.
Basically,
We say that
oversimplified,
neuron is just a node.
we say that neuron is
Which
just
has
a
several
node,
inputs connected to the
okay,
node.
which
So
has
let us
several
say
inputs connected
input
to the
1,
node.
input 2,
So
input
let us
3,
say
okay?
input 1,
I1,
input
I2,
2,
I3,
input 3,
In.
input n, I1,
Okay.
I2, I3, In,
And we do just one
okay,
thing that we
and we
multiply
do
these
just one
inputs
thing that we
with
multiply
the
these
weightage
input
factor. So we
with
multiply
a
them with
weightage
respective
factor.
weightage factor.
So we multiply
W1,
them with
W2,
respective
W3,
weightage
Wn,
factor,
etc.
W1,
And
W2,
we just do
W3,
this
Wn,
summation.
etc. And
Okay.
we just do
Now
this
some of
summation.
these may be plus sign, some may
Okay.
be even be
Now
minus
some of
sign.
these may be
Some
plus
input
sign,
come,
some may
it
even
makes
be
it more
minus sign,
difficult for
because
the
when some
neuron to
input
fire. Those
come,
are called
it
as
makes it more
inhibitory
difficult for
connections.
neuron to fire. Those
Something
are
which
called
will
as
preempt the
inhibitory
neuron from
connections,
firing.
something which will
So
preempt the
the sign
neuron
can
from
be plus
firing.
or minus.
So
Doesn't matter.
the sign can be plus or
But
minus. It doesn't
basically,
matter.
learning means
But
learning the value of
basically,
these weightages.
learning means learning the value of these
Now these are
weightages.
the weightages assigned to
Okay.
various
Now
inputs,
these are the
and if the
weightages assigned
sigma
to
is
various
exceeding
inputs,
some threshold, then
and
the
if the
output is
sigma
there.
is exceeding some
Okay.
threshold, then the
Now
output
this
is
is
there.
how neuron works.
Okay. Now this is how
Now,
neuron works.
depending on success rate, we
Now,
monitor the success
depending
rate,
on success rate,
and
we
let us
monitor
say
the success
frequency
rate
between success
and
and things
let
like
us say
that.
frequency between
The success, things like that.
rate of success, we can say
Frequency rate and severity rate
and
of
based
success,
on
you can
that
say
we
something
assign
like that.
and we learn
And
the
based
value
on that,
W1,
we
W2,
assign
W3,
and
W4.
we learn the
So
value
these
W1,
are
W2,
changes
W3, Wn.
which are
So
happening
these
through
are
learning.
changes
But
which are
otherwise,
happening through
this is the
learning.
kind of
But otherwise,
formula
this is the
which is
kind of
doing a summation, a
formula
weighted summation of
which
various
is
inputs.
doing a summation,
And
a
if it
weighted
is
summation
exceeding
of
some
various
threshold
inputs.
value, we are saying
And
that output
if
is
it is
there.
exceeding some threshold
Simple.
value, we are saying that output is there.
Now, are you with me?
Simple.
This is the
Now, are you
simplistic
with me?
neural model
This is the
when you do
simplistic
it through
neural
computer.
model
When you
when you
enunciate
do
a
it
neuron on
through
a
computer. when you
Hello,
emulate
sir.
a neuron on a computer.
Hello, sir.
Because we are not talking of any morphology or any transmission delay or anything of that sort. So we
Hello,
are
sir.
simplifying it and we are making it closer to digital. Okay.
Hello, sir.
So
Hello.
basically, based on success history, the weightages will evolve, and so that it become easier. Let us say with input number one, it has succeeded in giving an output many times. Then weightage for one will increase. The W1 will have a bigger weightage. And suppose for a long time it has not succeeded, this weightage will diminish. So it becomes more difficult for this input to make the neuron to fire. Simple. Okay. Now, are you with me?
Sir,
Any feedback?
are you able to listen my
Hello?
voice?
Yes, sir.
Hello?
Are you able to hear me, sir?
Sir, audible, sir.
Am I reaching you?
Yes, sir, you are audible, sir. Audible, sir. Sir, you are audible.
Hello? Can
Sir,
somebody
you
give
are
me an
audible, sir.
acknowledgement
You are
whether
audible,
this
sir.
message am I
Okay,
reaching
sir.
you or not?
Okay, audible.
Yes, sir. Yes, sir.
Okay.
Hello?
Audible, you
Sir,
can
you
Please
are
proceed.
unmute
audible.
and give me a
You
feedback.
are audible, sir.
You continued, sir, audible.
Yes, sir, you are
Hello?
audible. Audible, sir. Audible.
Mic, speaker. Chat left.
Hello,
Hello?
sir. Hello, sir. Hello. Come on, Joseph.
You're
I am
audible,
audible?
sir.
Okay,
Please
sorry.
continue, sir.
I was not able to see your messages. Fine, fine, fine. So should I go ahead?
You're audible, sir. You can go ahead.
You can unmute and actually give me a signal in voice because I'm not seeing this screen most of the time. Okay. Okay, fine. So I'll continue, assuming that fine. So this is what we have been saying, and what I have written is read is what actually happens in biological neuron. This is what we don't do when we simulate neuron in computer. Now here you have 1 minus exponent raised to the power something equal to e. Typical like capacitor charging discharging curve. Now that kind of things we don't do when we do neuron in machine learning. Okay. Now basically what machine learning does, basically we are used to equations like this. Let us say output is equal to ax plus by plus cz plus something something, several variables and several coefficients. Okay. So possibly with neural learning, deep learning, we are refining and defining the values of a, b, c and all these coefficients. And in case we have, let us say, raised to the power something, we have indices, we can learn that those indices as well. So basically through AIML, what we intend to do by a neural network is to determine the exact and to evolve the exact equation, okay, between variables and their coefficients and indices. Okay. Now this is
Hello.
basically what learning will do. It's
Hello.
something like nerves fitting, you know. In CNC machine, we have nerves interpolation. So when you have some points and you don't know what is the curve, what is the exact uh, polynomial which is passing through those points, then you do nerve fitting. So it is something like spline fitting or nerve fitting, basic spline fitting. Something similar to that you can do through neural network. So that is what is being achieved. And deep learning, what we do is, let us say there are number of inputs and there are number of outputs. In between, we put some neurons. So all these inputs, we assign, we learn some weightages, and depending on whether this fires or not, it doesn't fire, it will give an output to all these outputs. Simple. So this is a simple neural mesh, a single layer neural mesh. Okay, where there are inputs, input layer, output layer, and a single layer of neuron. In case of deep learning, we can have multiple layers of neural network where neuron can talk to other layer of neuron, other layer of neuron, and we can have number of layers, which of course in biological thing the number of neurons layer is also determined dynamically by learning. Now here in case of CNN, we actually pre-design the morphology. So we predetermine what will be connected to what all and how many layers will be there. That's what is we are doing as a fixed part. That is not a variable part. The variable part is only the weightages which are assigned for learning of individual neuron points. Correct? So that is how it will work. Now let us say we make a program to identify the handwritten characteristic. Now I spoke of industry 5 and I said that the machine has to deal with vagaries and variability of human behavior. Now one variability that we have, let's suppose somebody is writing handwritten text. Okay. Now sometimes somebody will write a single character in different way. Let us say there is a 3. Okay. And let us say we have a 28 pixel by 28 pixel matrix. Okay. Now somebody may write 3 like this, somebody may the okay. So but as human we are able to make out that it is 3. Okay. Whether somebody writes like this or like this or like this, it's all 3. Okay. Now how do we make computer to identify this variability and still infer that it is 3? Correct? So how do we say, because there will be variability, same person may write it differently, and it should not confuse between, let us say, 3 and 5. Okay. So basically let us say we have a matrix of pixels. Wherever light is falling, we say those are 1, those cells are 1, and remaining are 0. Correct? So let us say that we have so many pixels determining the rows and columns, and here we are writing some character, handwriting. Okay. Some things are bright, some things are light, dark. The dark ones are dark here, and the lighted ones are shown shaded. Okay. Right. Now what we can do is we try to simulate the human behavior. Now here we are pre-connecting the neurons into some 4 layers in this case. Okay. Let us say depending on intensity pattern, we are not saying that all the cells are equally bright. Okay. Let us say that intensity of light varies from 0.1 to 1. Okay. Now depending on this intensity pattern, we map the intensity pattern and we read them in a particular way. So totally there are 784 cells, rows and columns put together in a line. Right? The cells which are brighter, which receive some light, they will have different fractional numbers. The numbers are always fraction. Let us say 0 to 0.99 or 1 maximum. Okay. 1 is full bright. So let us say 1 or less than 1, you have some value. Okay. So let us say you place them like this, all 784. So you will have some intensity pattern here. Now you have another layer and another layer, and finally we are having 10 output 0 to 9. Depending on what is the identified character, you light up just one of these. Okay. With certain probability, of course. May not be always 1, but it will be, let us say, 80% probability that what you have written is 9. So it will highlight that number. Okay. So the question is, what for are these 2 middle layers and why 2 middle layers? Now why 2 middle layer is when you say that the characters are there. Okay. Now characters are made up of some straight lines, some loops, sometimes 2 loops, one loop above and one loop below, one line above and one tall line, one short line and one horizontal line. Correct? So basically last but one layer is identifying these elements, whether you have loops or you have short line or long line, and whether it is at top or bottom. So based on that, you are deciding the probability that what has been written is probably 4 or 3 or 2 or 1 or 0. But only one of these is allowed at a time. Okay. But what for are these layer, that second layer? The second layer is to break the circle into arcs. Let us say 4 arcs are there. So you are trying to figure out whether it is a loop or a line. If it is a loop, whether it is at the top or it is at the
To
bottom.
identify a loop,
Correct.
you use the second
So
layer
to identify
because
a
you're
loop,
just trying to
you
identify
use the
that yes,
second
whether
layer
there are four pieces
because
like
you are
this,
just trying to
four
identify
or
that
five
yes, whether
segments
there are
which
four
are
pieces like
making a
this,
loop,
4 or 5 segments
or there are
which
multiple
are
vertical
making a
segments
loop,
which are making a vertical line.
or there are multiple
Right?
vertical segments which are making a vertical
Now
line.
this is what is done by second
Correct.
layer, and third layer
Now this is
is
what is done by second layer,
deciphering the combination
and
of loops
third
and
layer
lines, and
is
finally you have the
deciphering the
character
combination of
recognition.
loops and lines,
This is the
and
output. This is
finally
the input.
you have the character recognition.
Okay.
This is the
Now this
output, this
was
is the
an
input.
illustration of
Okay.
how
Now
neural
this was an
networks
illustration
are used.
of how neural networks are
Correct?
used.
How neural networks are used.
Correct. How neural networks are used.
This is a simple way in which it is
Correct.
done. Hello, sir.
This is the simple way in which it is
So
done.
this is the way
Hello,
the
sir.
machine learning works.
So
This
this
was an
is the way
introduction to machine
the
learning.
machine learning
Now let
works.
us quickly
This
come
was an
to what do
introduction to
we do
machine
as
learning.
mechanical
Now
engineers
let
with
us
all this.
quickly come to what do we
Now these
do
are
as
the
mechanical
methods.
engineers
All
with all
right.
this.
Supervised learning,
Now these are the
unsupervised
methods.
learning,
All right.
feedback based learning,
Supervised learning,
identifying between cat
unsupervised
and dog.
learning, feedback
Fine.
based learning,
But what
identifying
do we
between
do
cat
as
and dog.
mechanical engineers?
Fine.
Now let me come to the
But what
mechanical
do we do
engineering
as
aspect
mechanical
in the second
engineers?
half of
Now
my
let me
talk.
come to the mechanical
Now,
engineering aspect
one of
in
the
the second
of course
half
there
of
are
my talk.
several applications and
Now,
possibly I can't
one of the applications, of
cover
course, there are
everything,
several
but I will
applications
just
and
try to give
possibly I can't
some variety.
cover everything,
And of
but
course
I'll
there
just
are
try
other
to give
speakers following
some
me,
variety.
so they will
And
take
of
care
course,
of the
there are
rest.
other speakers following me, so they will take care of the rest, I
You
believe.
must all of you must
Now,
have done some point in time about the control
all of you must
engineering
have done some point in time
book
about
by
the
Kuo
controls,
Ogata,
control
Nagar Gopal,
engineering,
and things
this
like that in
book by
engineering.
Kuo
So
Ogata, Nagarath
basically,
Gopal,
any
and things
closed
like
loop
that
control,
in engineering.
what we call as
So
servo
basically,
control.
any closed loop control,
Okay,
what we
we
call as
have
servo
negative
control.
feedback. We have a set point.
Okay,
We have the
we have
feedback.
negative
We
feedback,
subtract
we have
feedback
a
from
set point,
command,
we have the
and
feedback, we
we
subtract feedback from
multiply the
command,
proportionality
and
factor to
we
take a corrective action
multiply with the
through the
proportionality
control
factor
device.
to take a
We have
corrective
a
action
ramping through the
through the
integration.
control device.
Okay.
We have a
So that
ramping
we have a
through
soft start
integration.
and soft
Okay,
stop.
so that we
And
have a soft
in
start
order to prevent
and soft
drifting,
stop.
we jack up
And
the
in order
slowly
to
varying
prevent
drift
drifting,
by
we
differentiating
jack
the
up
feedback.
the slowly
So we
varying
have
drift
a
by
factor called as
differentiating the
P,
feedback.
I, and D.
So we have a factor
Proportionality,
called as
integration,
P,
and
I, and
derivative
D.
coefficient, which are
Proportionality,
basically
integration,
multiplying
and
factors
derivative
to the
coefficient,
feedback based
which are
control.
basically
And
multiplying
finally,
factors
based on
to the
combo of
feedback
these,
based
an action is
controls.
taken.
And finally, based on combo of
The
these,
role of
an action
PID
is
is
taken.
basically you have
The role of
electronic
PID
system
is
and you have a
basically
mechanical
you
system.
have an
Now,
electronic system
obviously,
and
electronic
you have a
system
mechanical system.
responds much faster.
Now,
Doesn't have to do
obviously,
anything. It can
electronic
respond in
system responds much faster.
nanosecond
It
also,
doesn't have to do anything. It can
microsecond.
respond in
But for mechanical time,
nanoseconds
suppose
also
there is a
or
big inertia, there is
microseconds.
a big damping.
But for
It
mechanical
will
time,
take
suppose there is
some
a big
maybe few
inertia, there
seconds
is a
to
big
respond,
damping, it will take
not minutes.
some maybe few
Right?
seconds to
So
respond,
somewhere we
if not
have to
minutes.
marry
Correct?
the
So
mechanical
somewhere
response time with
we
the
have
control
to
response.
marry the
The control
mechanical
can be
response time
instantaneous,
with the control response time.
but control may
The
assume
control
that
can be
mechanics is
instantaneous,
not responding because it is
but
not
control may
responding
assume
faster.
that mechanics is not
So
responding because it is
basically,
not
the
responding fast
control
enough.
has to be taught
So
that
basically,
realistically
the
this is the
control has to
response
be
time of
taught
mechanical system.
that
Therefore, you
realistically this is
expect
the
this much
response time of
delay, this
mechanical
much
system.
integration, this
Therefore,
much
you expect this much
dissociation,
delay,
this much
this much
proportionality.
integration, this much
Now, it is
differentiation, and
absolutely
this much
necessary to
proportionality.
have optimal
Now, it is
value of
absolutely
P, I, and
necessary
D
to have
to have
optimal
a
value of
good
P, I,
dynamic
and D
response of
to
control.
have
Correct?
a good dynamic
Otherwise,
response of
you
control.
make
Correct?
proportional constant too
Otherwise,
large,
you
let us say
make
this P decline.
proportional constant too
Now, this
large.
is
Let
very
us say this
large
is
and
P
these two are
beside this is
nearly
D.
zero. These are
This
very low.
is very large and these
Now, you
two
will
are
have a lot
nearly
of
zero.
ringing,
These are very low.
overshoot,
Now
undershoot.
you will
So
have
it will
lot
go
of
on
ringing,
oscillating for a long time before
overshoot,
attaining the
undershoot.
final
It will go
value,
on
and it will
oscillating
take a
for
lot
a
of
long
time to
time before
attain the
attaining the
final value of
final value,
which is
and it will take a lot
not
of time to
acceptable
attain the
from
final value
controls.
also, which is not acceptable
Okay.
from
Now,
controls.
if you make it too low,
Okay.
probably it will
Now,
saturate
if
short
you
of
make it
reaching the
too
final
low,
value. So
probably it
midway
will
itself it
saturate
will give
short of
up.
reaching the final value. So
It
midway
is unable to
itself, it
reach
will
the
give up.
commanded value.
It
So
will be
this
unable to
also
reach
can
the
happen.
added value only. So this also can happen if this is deemed to be too low. So it cannot be too high, it cannot be too low, it has to be optimal. And what is the optimal must be determined through AIML. That is the application. Otherwise, somebody manually tries by hit and trial attains the magic figures of P, I, and D, then the system works fine. Otherwise, now this is what is critically damped system. Overshoot is a little on higher side, but this is still settling very fast, and there is not too much of ringing. One overshoot, one undershoot, and after that, pretty much it is stabilizing. Okay. Now this is what is called as critically damped. Now this is the optimal value of P. But in order to kill the overshoot, you have to increase the differentiation. You have to have the integration. Now this is in nutshell what happens if you have inappropriate selection of P, I, and D. Okay. So if you increase this, then rise time will decrease, overshoot will increase, settling time, there will be a small change, steady state error will decrease, stability will degrade. So also this, so also this. Okay. So this will slow down the correction. Here it will lose the accuracy of control. Right. So therefore, you must have a proper selection of P, I, and D. Now, normally, in absence of, it's not that we are not doing tuning for servo controls before AIML was born. We were doing, but we were doing it by hit and trial. And what we did was we used to give a step command, and we used to see overshoot, undershoot. Then we used to work back, and we had some equations, and we used to determine the calculated value of optimal P, I, and D, and we used to set them. Okay, correct. Now that was the rigorous way. In absence of AIML, right? Now, how AIML will change? And suppose you are talking of a CNC machine, for example. The depending on the load, if suppose you have a moving table on the machine and it's carrying load, sometime it may be carrying 10 tons, sometime it may be carrying half a ton. Now, obviously, the inertia is changing, so PID cannot be same. The mechanical response is variable at times. So every time you have to determine the optimal value of PID and set before you set out in the machining cycle. Correct? And you may have different set of parameters for roughing, semi-finishing, finishing, depending on the load, depending on force, depending on size of job, depending on overhang, movement of CG, and so on. Correct? So one way is that you just learn it out of experience, and you have a lookup table and you find out what is the best value in this given circumstance, and you set that one. Okay. And what AIML can do is, suppose you build in, let us say, an accelerometer to add an additional sense to the machine, where it can sense the vibration, it can sense the overshoot, undershoot. Okay. So based on load carried by the table, as the machine starts moving, the control can determine the extent that tuning has to be tweaked for the optimal response. Okay. And that learning can happen through AIML, so that it will adaptively set those optimal parameters on its own without having to do it manually, without having to trouble the operative and the engineers in maintenance. Okay. And based on cutting operation, based on cutter, based on whether you are going to take a big cut or a small cut, based on size of job, based on where you have placed the job on the table. Okay. It can determine the optimal parameter of PID, right? And of course, you have the past learning. So as the control will go on learning, it is reinforcement learning, feedback based learning. So it will go on refining those lookup tables. So it will find out the best values under a given circumstance. Correct? And it will automatically select the best matching values through AIML. Now this is one of the application. Fanuc has reported some lot of such case studies in our seminars that my organization does from time to time. And we also say that for the test, there is something called as feed forward control in controls. We say, why do you want to give a step waveform to test the response? If you expect that the system is going to respond in a certain way, you can also modulate the command. So you pre-tailor the command itself in view of the learnt mechanical response of the system. Now that is called as feed forward control. Feedback control means you totally don't know how the mechanical system will respond. But through AIML, you surely can learn how your mechanical system is responding, how it has been responding. So instead of feedback control, you can go for feed forward control. And you can tweak your command itself. You can tailor your command to get the best response. Okay. So this is another area where command to PID itself is modulated according to the anticipated behavior, mechanical behavior of the system. Okay. So, and when the CNC is cutting, let us say a job, there are several passes. From the previous passes, it knows where it is encountering a step and there is a sudden surge in current. So it can slow down well before that. Okay. It can modulate the command, it can modulate the speed feed accordingly so that it will get the best possible performance on the machine. And it will minimize the vibrations, it will minimize the scatter marks in anticipation. Okay. Because all that learning will dynamically happen as the machining is going on. So maybe first pass there will be a problem, subsequent passes it will learn where problems are anticipated. It will take preventive measures, preemptive measures before reaching there. Correct?
Hello, sir.
So
Hello.
now AIML
Hello.
is the kind of a shortcut I always say. One thing is that you apply the basics of engineering fundamentals. One more thing you can do, suppose you want to kill the vibrations. That is the aim finally. So you can also have something called as active damping. Now in active damping, what do? You record that vibrations are happening and in real time, you counter those vibrations through a piezo element which will make a counter movement to the impulse movement, to the detected movement. So that is called as active damping by employing an adaptive control. Now this is an adaptive control. Now adaptive control is not AIML. Adaptive control is adaptive control. And adaptive control is a more rigorous engineering fundamental than AIML also. But AIML is a kind of a shortcut. Using a piezo element and doing active damping is not everybody's cup of tea. But making refining the values of PID, learning where to slow down, etc., is something which can be easily done at lesser cost. So AIML is a kind of a shortcut, I would say. Though as an engineer, yes, adaptive is closer to my heart. Active damping is closer to my heart because that is a more rigorous science, right? But then AIML is a shortcut. It is a prediction-based strategy to modulate the drive and to optimize the dynamic response based on past learning. Okay. It's a kind of techno astrology, if you please. Yeah. You have learned on the past empirical data and you are predicting mishaps in the future. Right? So technically, which is more rigorous from engineering fundamentals, obviously, adaptive control and active damping is more rigorous mathematics. But AIML is a shortcut. Second application that I intend to talk is adaptive compensation for thermal variability of large size machines. Let us say you have very big machine. Now machine like this, you have a moving table, okay, and you have two columns, fixed columns, and on top you have a cross beam, this black thing, and on this one you have a moving saddle and a ram, and here you have a spindle, and of course table is moving in x-axis. This is y-axis and this is z-axis, the spindle up there. Correct? Now look at the size of the machine. Suppose your job itself is 4 meter by 2 meter or some such like, weighing 20 tons of steel, mild steel, okay, or casting. And you expect to do boring in 10 micron and 20 micron P3. But what is the thermal coefficient of steel? It is approximately 10 micron per degree per meter. And our job size is 4 meter and machine size is 6 meter. And job is a mass of steel, so also machine is a mass of steel. Or maybe the job is aluminium and machine is steel. It makes the matters even worse. Correct?
because they will have different thermal
our
expansion
shop
rate.
floors are
Correct?
not air conditioned
Now,
and
what will
they better
happen?
not be
And
air
our
conditioned
shop floors are not air
because the
conditioned and
connected
they
load of
better
machine is,
not be
let
air
us say,
conditioned
120 kilowatt.
because
So
the
120
connected load
kilowatt
of
worth of
machine
heat is
is,
what
let
you
us
are
say,
generating
120
inside.
kilowatt.
What will be the rating
So
of AC
120
if you have?
kilowatt worth of heat is what you are generating inside.
And where all
What will be the
the
rating of
AC will
AC if you
maintain
have?
20 degrees at the
And
point
where
where
all,
its
see, AC
thermocouple
will
is.
maintain 20 degrees at
But where
the
all you can put
point
thermocouple?
where
Suppose
its
your thermocouple
thermocouple
is.
is.
So where will you take the
But where all you
feedback?
can put
At the
thermocouple? You can
spindle,
put it at only
at the
one place.
table, at the
So where will
job,
you take the
at
feedback?
the top of the
At the
machine,
spindle,
the bottom of
at the
the
table, at the job,
and everywhere
at
the
the top of the
temperature is going
machine,
to be
at the
different,
bottom of the
can't be
machine?
same.
I don't. And
And
everywhere the
in
temperature is
my
going to be
city,
different,
that
can't
is
be same.
Pune, the daily
And
temperature variation
in my
nowadays
city,
of the order
that
of
is
20
Pune,
degrees,
the daily
maximum to
temperature
minimum,
variation nowadays is of the order of 20
like from
degrees,
12 degrees to
maxima to
38
minima,
degrees. What are this?
right from 12 degrees to
So
38
if I
degrees.
have 4 meter job,
What is
4
this?
multiplied by 50 degrees,
So if I
that
have
is the
4 meter job, 4
that is
multiplied
what
by
my machine
50
and
degrees,
job is breathing.
that is the
Without
inaccuracy. That
considering
is
machining
what my
forces and
machine and
deflections
job is
and
breathing,
vibration. Forget now.
without considering machining
Even in
forces and
standing
deflections and
still,
vibration.
that
Forget
much
those.
it is vibrating. If I put a
Okay.
dial and do
Even
nothing,
in
the dial will shake
standstill,
by 0.5
that
mm.
much it is vibrating. If I put a dial
So
and
if
do
0.5
nothing, the
mm
dial
is
will
what
shake
my
by
machine is
0.5 mm
breathing, and
easily.
I expect 10 micron and
So
20
if 0.5
micron,
mm is what my machine is
the
breathing,
gross
and I
mismatch.
expect 10 micron and 20 micron
Right?
accuracy. It's
Now,
a gross
but big
mismatch.
jobs are there, big machines are
Correct?
there,
Now,
accuracy is
but
required for it.
big jobs are there, big machines are there,
So what
and
do we do?
accuracy is required for application.
Now let us consider what is
So
going to
what do we
happen
do?
on this kind of machine. Suppose
Now
temperature
let
goes
us
up by
consider
10
what is
degrees.
going to happen
I am
on
being
this kind
modest.
of a machine.
So okay,
Suppose
these two
temperature
pillars
goes
will
up by 10
expand.
degrees.
Let them
I am
expand.
being
Doesn't
modest.
matter. We'll adjust
So
in Z
okay, these two
offset.
pillars will expand.
So we shift
So
the
let them
program down.
expand. Doesn't matter.
And
We'll
spindle may
adjust
also
in Z offset.
elongate.
Okay, we'll shift the program
And
down.
table may also become
And
taller.
spindle may
Fine.
also elongate.
Let it become, we'll take care in Z.
And table may
Z
also
offset.
become taller. Fine.
The problem
Let
comes
it
when this
become, we'll
cross
take care
beam
in Z,
elongates.
Z offset.
What will happen?
The problem comes when
This
this
top
cross beam
beam
elongates.
will become
What
like
will
a
happen?
banana.
This top beam
And it will not
will
become
become
like
like a
the
banana.
same banana every day.
Okay.
One day
And
it
it
will
will
be
not
a
become
straight
like a
banana
same banana
curving
every
up.
day.
Other day it
One
may be
day it
curving
will be
down.
a straight banana, means curving up.
Third day it may be
Other
curving
day it may be
forward,
curving down.
curving backward,
Third day it may be
curving
curving
130 degree
forward,
plane, 135 degree plane.
curving backward,
It
curving in
will
45
be
degree plane,
not be
135 degree
repeatable.
plane. Oh
And
my God.
along with this,
It will
because
be not be repeatable.
columns may
And
bend outward.
along with this, because
So someday something will happen,
columns may
someday
bend
this will bend
outwards.
more, something that will bend more.
So
It is
someday
not
something will
something which
happen,
will be
someday this will
anywhere
bend
near
more, something
repeatable.
that will
So
bend
you
more.
can't
It is
pre-compensate.
not something
You
which
can't
will be
determine and
anywhere near
compensate.
repeatable. So you can't
And
pre-compensate. You
with
can't
this
determine and
distortion, you
compensate.
are losing the geometry of the machine, you
And
are losing the
it
orthogonality
is
between X, Y,
distortion.
Z.
You are losing the geometry of the
That is
machine. You are
distortion.
losing the orthogonality between X,
So
Y,
it's
Z
not mere thermal expansion,
when
it is
these
distortion,
distortions happen.
gross distortion.
So it's not mere
So how
thermal
does one
expansion,
take
it is
care of this
distortion,
gross
gross
distortion?
distortion. So how does one take
Now
care
only
of
thing
these
is we
gross
say that
distortions?
we have to remember Lord
Now
Shiva
only thing is
and
we
his
say
third
that
eye. So
we
what
have
we
to
do,
remember Lord Shiva
reverse way,
and his third
that
eye.
we put some targets on
So
the
what we
structure of
do?
the machine.
Regress way,
Okay, let us take
that
some
we put
target
some
here,
targets
here,
on the
here,
structure
on
of
the
the
table,
machine.
on the columns.
Okay, let us set some
And we
target
have
here,
some
here, here,
two
on the table, on the columns.
optical inspection systems
And we
outside
have
the
some
machine.
two
The Shiva's
optical
eye,
inspection systems
who will look
outside
at
the
the
machine.
machine and
The
determine
Shiva's eye,
the way the machine distorts
who will look at the
on a
machine
given day.
and determine the
And
way the
based on
machine
the actual
distorts
distortion
on a given day.
calculation, it will
And
dynamically
based on the
advise the
actual
compensation
distortion
suitably to the CNC.
calculation, it
How
will
do you like it?
dynamically
Now this
advise
is
the
the regress way,
compensation suitably to
adaptive.
the CNC. Now, how do you like it?
But
Now,
what
this is the
AIML
regress
will
way,
do,
adaptive way.
AIML
Okay.
will say that
But
okay,
what AIML
ultimately
will
what
do,
matters is the inaccuracy that is
AIML will say
transferred
that,
on the
okay,
job.
ultimately
So
what
it is
matters
the
is
relation
the
between spindle
inaccuracy
and
that is
job.
transferred on
So
the
let
job.
us not worry about
So,
rest
it
of
is the
the
relation between
structure.
spindle and job.
Okay.
So, let
So
us
what
not worry
AIML
about
will
rest of
do
the
is
structure.
a large number
Okay.
of jobs who
So, what
actually study
AIML will
under
do
different conditions.
is a large
And the
number of
variables
jobs who
are
actually study under
ambient
different
temperature,
conditions.
maximum
And the
temperature,
variables are
temperature of spindle,
ambient
temperature at
temperature,
temperature, maximum temperature, temperature of spindle, temperature at various places on the machine, plus not just the temperature gradient, dt by dt, that is rate of change of temperature.
Because all these
What
variables
is the
may
rate of
contribute
increase or
to
decrease of
structure
temperature?
getting distorted differently.
Because all these variables may contribute to structure getting distorted differently.
Based on a lot of
Right?
observations on the actual inspected
So
data,
based on lot of observations on the actual inspection data, actual cheddar marks, actual inaccuracy on the jobs, you generate lot of learning through AIML, and you determine those compensations through AIML. Okay. Now this is what is this is what I have explained already. Okay. So all these variables, the gradient, rate of change, etc., you learn based on that, and also you can correlate further with what the depth of cut, what was the cutter, what was the speed feed, and under all these conditions you gather a lot of data and you correlate it with the final result, inspection result of the job, and based on that you learn the compensation, whatever was the polarity of error on the job, magnitude and error in different places. Based on that, you advise the compensation in the different situations. So AIML, as I said, is a kind of shortcut to rigor of engineering. It's a shortcut which will give you the solution, a reasonably good solution, acceptable solution, will solve the problem without having to go through the rigor of engineering and go through details. Right? So I understand as mechanical engineer, I would like to go in the rigor as academic person, but then this is a shortcut. So AIML gives us a shortcut to take care of the solution. So this is what I have said. This is the rigorous method. Observe some targets placed from external inspection and determine the exact distortion, magnitude and mode, and advise dynamic compensation, or based on inspection data of machine part, correlate it with various variables. Statistically, you find out what is the relative probability of what compensation doing what, and based on that you pick up, and maybe you can have a neural model, multi-layer neural model, to find out what is the best compensation in a given situation. Right? Correct. So this is another application which was little different. Third application is improving dynamic precision of a machine tool. Now consider a machine tool. Now normally in machine we assume that mass is a mass and spring is a spring, but spring has a mass and mass has a spring actually. Okay. So that be the case, let us say this is the structure of machine, it does have some spring actually, even if this mass is resting directly. So when it is moving, it is actually moving little bit back and forth. So when you move, let us say delta x, okay, there is also a component delta z which comes automatically, because the thing will shake, it will oscillate as if it is resting on two springs. Okay. So basically this is something that is giving us dynamic inaccuracy. In the machine, there is something called as static precision and something called as dynamic precision. Dynamic precision is something that is dependent on the rate of acceleration and stuff like that. The mass, the acceleration, the rate of change of acceleration, and so on. Right? Now, these things, normally in laser calibration, you can't determine these things. Okay. But if you have some instrumentation, and let us say you have a laser interferometer only, and you make the machine to go through actual machining cycle while measuring it, or you may use laser tracker, which is even better, more effective. With laser tracker, you are able to track acceleration, you are able to track velocity and also displacement. Correct. So you are able to find out these magnitudes, and you can learn under different situation with different acceleration and braking how much are these movements. One can learn, and then while impressing these kind of acceleration, you can pre-compensate the geometric error by so much, so that the dynamic machining is more accurate, because machine will never stop and actually do machining, machine will keep on accelerating, right? So dynamic precision is actually important, and for heavier machines it plays havoc, these kind of things. Okay. Now all these kind of correlationals can be learned, and if you improve the dynamic precision, you will, let us say, get a plane, a perfect circular interpolation. Otherwise maybe you will have some plane face here, okay, due to this.
effect of elastic
on
deflection
flattening on
with
circular
sudden
interpolation,
acceleration and sudden
right?
reversal.
So this
You
kind
may
of
have some
crosstalk
flattening on
compensation,
circular interpolation,
crosstalk between axes,
right?
the effect
So
of
this
center of
kind of
gravity,
crosstalk
the effect of
compensation,
overhang,
crosstalk between axes, the
which
effect of
can be
center of
learned and
gravity,
this can be
the effect of
negated
overhang,
through AI.
okay, this can be learned and this can be
So
negated
also
through AIML.
active vibration damping could be attempted.
So also
Okay.
active
I'm
vibration
saying
damping could
optimizing
be
the
attempted.
parameters,
Okay,
optimizing the acceleration in PID.
I am saying
I'm not saying that
optimizing the
active damping
parameters,
in the sense that you sense the
optimizing the
magnitude of
acceleration in
vibration and
PID.
have counter
I am
vibration.
not saying that
Not that way.
active damping
That
in the
is
sense that you
rigorous
sense the magnitude
engineering.
of
That is
vibration and
not
you have
AIML.
counter vibration.
But
Not that
selection
way.
of parameter up
That
to
is
there you can
rigorous
say it is
engineering.
AIML.
That is not AIML.
Now
But
with all these
selection of
things, maybe
parameter
we
up to
can
there, you can say it is
have a
AIML.
control on ringing at the
Now
corners
with all these
wherever
things,
there will
maybe
be
you can
direction
have a
change.
control on ringing at the
You
corners
compensate
wherever there is a
the proper
direction change.
parameters,
Okay,
you may
if you
get much better.
compensate
The
with
effect
proper
on surface
parameters,
quality, the effect on
you may
chatter
get
marks
much better result.
could be seen with these kind
The
of
effect on surface quality, the effect on chatter
position
marks
dependent active
could be
control
seen
you can
with these
have
kind of
when there is an
parameters.
overhang. Let us say you have a
Position
boring machine
dependent
when the
active
spindle
control
comes
you
out,
can have
it
when
sags
there
due
is
to
an
center of
overhang.
gravity.
Let us say
Now you can
you have a boring
pre-compensate.
machine, when the spindle comes out,
You
it
can
sags due to center
pre-compensate
of
the
gravity.
PID
Now you
parameters
can
when we have a
pre-compensate.
geometrical error.
Okay, you can pre-compensate the PID parameter. You
And
can
also whether the
pre-compensate the
table is
geometrical
laden
error
or
also.
unladen, its dynamic behavior will change.
All
So
and
again,
also whether
PID
the table is
parameters in
leaden or
relation with
unleaden,
mass
its
carried on the
dynamic
table.
behavior will change.
You
So
could
again,
have some
PID
learning,
parameters in
load
relation with
dependent adaptive
mass
control
carried
you
on
can
the
realize.
table, you could have some
In
learning.
short, the
Load
use of
dependent
AI in
adaptive control you
machines
can realize.
is made to compensate for
In
dynamic
short,
response,
the use of
dynamic
AI in
accuracy
machines
improvement, for
is
variable
made to
inertia system,
compensate for dynamic
for
response,
noise
dynamic
suppression,
accuracy
for
improvement,
cancellation,
for
for
variable inertia system,
optimization
for
of
noise
parameters,
suppression, for
for
cancellation, for
compensating of effect of CG shift, sag,
optimization of
overhang,
parameters, for
to negate the
compensating of
effect of
effect
play,
of CG
backlash,
shift,
deflection,
sag, overhang,
vibrations.
to negate
All
the effect
these
of play,
could be
backlash,
addressed through
deflection,
AI,
vibrations.
particularly in
So all
larger machines.
these could be addressed through
Now
AIML,
coming to the machining part,
particularly in larger machines.
there is
Now coming to the
adaptive
machining part,
machining is possible.
there
Now,
is adaptive
let
machining
us
is
say
possible.
you record the
Now
data. Now, some
let us
of you may
say
be knowing this gentleman,
you record the data.
Professor Jha from IIT
Now
Delhi.
some of you may be knowing
Now,
this
FSM
gentleman,
is doing pioneering work in this field
Professor
in
Jha
his
from IIT
laboratory.
Delhi.
And these are some of the
Now
slides
FSM
from
is doing
one of his
pioneering work in this
presentations
field
that he
in his
made in
laboratory.
one of our
And
seminars.
these are some of the
So,
slides
for your
from his
benefit,
one
I
of
am
his
giving you
presentations that he made in
courtesy
one of our
professor.
seminars. So for
So,
your benefit, I am
basically,
giving
you
you
record
courtesy,
speed, feed, vibration,
Professor.
temperature, energy,
So
and coolant.
basically,
Coolant
you
flow, coolant
record
temperature, respectively.
speed, feed, vibration,
So, these are
temperature,
your
energy,
variable
and
data.
coolant.
And the
Coolant flow,
output
coolant
is
temperature,
actually
energy.
form deviation and
So
RA
these
value
are your variable data,
obtained on the
and the
machine.
output is actually form deviation and RA
Now, if
value
you do that, you
obtained on
will
the machine.
be able to learn.
Okay. Now, if you do that,
You can
you
learn the
will
rate of tool
be
wear, for
able to
example,
learn.
and you are able to reasonably
You
well
can learn
predict
the
within
rate of tool wear,
95%
for
accuracy
example,
or more
and you are
that
able
at
to
what rate the
reasonably
tool
well
will wear
predict
out,
within
and
95%
accordingly
accuracy
you
or
may
so
compensate the tool
that at
dimension.
what rate the tool will wear out,
Right.
and
So
accordingly you may compensate the tool dimension.
for tool wear
Right.
compensation, learning could be
So
used for
for
surface finish,
tool wear
selection
compensation,
of
learning could
optimal
be
value
used.
here. You
For
can learn.
surface finish,
Now this is
selection
something
of
what I call as
optimal values
adaptive
here,
machining.
you
Based
can
on
learn.
learning, AI/ML based
Now
learning,
this is
you
something
optimize
what
the
I call as
machining
adaptive
parameter
machining.
so as to get a
Based on
good finish.
learning, AIML based learning,
Now
you
this could be in
optimize the
turning, it
machining
could be in
parameter
milling also.
so as to get a good finish
Okay.
on the job. Now this
So
could be in turning, it could
basically,
be in milling also.
conventional machining
Okay.
processes you do some machining and
So
then you inspect the job, you get
basically,
some geometrical errors, you
conventional
get some
machining
thermal
processes, you
deformations,
do some
elastic
machining and then you
deformations,
inspect the
etc.
job, you get some geometrical errors, you get
So
some thermal
basically you
deformation, some
negate
elastic
these to
deformation,
learn
some
those
vibration.
parameters
Okay.
and you are able to
So
control
basically, to
errors
negate
on
these,
account of
you
these.
learn those parameters and you are able to
In a way,
control the
in a
errors on
sense, what
account
I
of
talked
these.
earlier about the thermal
Right.
deformation of the large machine,
Now,
this
in
is
a way,
also coming here.
in a sense, what I have
This
talked
is of course
earlier
for
about
much
the
smaller
thermal
machines.
deformation of the large machines, this is also coming here.
Laboratory.
This is, of course, for much smaller
So
machines.
tool
This is
condition, you can predict after how
laboratory.
many hours of machining under different conditions of
So tool
vibration,
condition, you
how
can
they will
predict
wear out,
after
when
how
they will
many
wear
hours
out,
of machining under
etc.
different
And
conditions
you
of
can
vibration,
either
how they will
avoid the
wear out,
replacement or
then they will wear out. etc. And you can either advise a replacement or you can compensate the dimension so that you get the better quality, or you modulate the speed feed so that you get a better job out of the same condition. And you are able to predict the surface roughness, RA value, etc., and also the geometrical error.
Suppose you have a CNC machine
Now, this is what I was
with
saying.
number of tools in ATC.
Suppose you have a CNC machine
Now, how do you
with
determine
number
the
of
life of a
tools
tool,
in
the
ATC.
residual life of a tool?
Okay.
You
Now,
won't
how
know
do you
how many
determine the
hours
life
the
of a
tool has
tool,
been in use
the residual
and
life of a
what
tool?
duty the tool has been used.
You won't know how many
So
hours the tool has
basically,
been in use
we
and
learn
in what
something like
duty the
this,
tool
that
has
we
been
have a
used.
vibration probe.
So
Let us
basically,
say the
we
vibration
learn
level is
something
between
like
0
this,
to
that
2
we have a
units.
vibration probe.
We say that
Let
1
us
hour
say
of fuse
the
is 1
vibration
hour of
level is
life.
between 0 to 2 units.
Correct? What is
We say
vibration
that 1
level
hour of
between
fuse
3
is
to
1 hour of
3.5?
life consumed.
1
Correct?
hour fuse
But if
consumes 2
vibration
hours
level
of
is
life.
between 3 to 3.5,
And somewhere
1
here,
hour of fuse
in the
consumes 2
extreme
hours
case,
of life.
vibration value between 8 to 9
And
units.
somewhere here,
1 hour fuse in this
in the
condition
extreme
consumes
case,
150 hours of life.
vibration value between 8 to 9 units, 1 hour of
So
use in
all
this
you have to
condition
do
consumes
is to
150 hours of
record the
life.
vibration level
Right?
and
So all you have to
find
do
out
is to record the
how
vibration level
many hours you have used the machine under
and
what condition,
find out
and based on that,
how
what is
many
the
hours you
total
have used the
sigma
machine under
of
what
life
condition,
consumed, and
and
therefore
based
what is
on
the
that,
residual life.
what is the total sigma of life consumed,
Now here,
and therefore what is
I
the
have
residual
given these
life
values
now.
just off the hat.
Correct? Now here
But AIML
I have
helps you
given
to
these
determine these
values
values.
just off the hat. Okay, but
I hope I'm
AIML
clear.
helps you to
Yeah.
determine these values.
So with use of AIML, you
I
will
hope
be
I'm
able
clear.
to predict
Yeah.
the life
So
of
with
cutter
use of
much more
AIML,
reliably,
you will be
faithfully.
able
You
to
will be able to
predict
monitor.
the
You
life
don't
of
use
cutter
a
much
worn
more
out tool
reliably, faithfully.
so
You will
that
be
your
able
job
to
will not be
monitor.
rejected.
You don't
And you will
use a worn
optimize
out
the
tool
use tool. You will not throw the tool before
so
it is
that your
worn out.
job will not be rejected.
Correct?
And you will
So
optimize
from
the
cost
use
point of
tool. You
view
will not
and
throw
from
the tool
quality
before
point
it
of
is
view,
worn
this is
out
the
and
best
so on.
bet. That
Correct?
AIML
So from cost point of
is
view and from
used to
quality
learn
point
the
of view, this is
multiplying
the best
factors
bet.
here in the middle
That
column.
AIML
Correct?
is
And
used to
therefore you
learn the
predict
multiplying
the
factors
residual
here
life of
in the
tool
middle column.
accurately.
Correct? And
Correct?
therefore you predict the
Now this is
residual
a case
life of
study.
tool
This is just a
accurately.
report of
Correct?
what kind of accuracy you
Now
get
this is a case
through
study. This is
AIML.
just a
So let us say
report
tool
of what
wear
kind of
monitoring.
accuracy you get
It is
through
accurate to
AIML.
90 plus percent,
So let us say
90.26%.
tool wear monitoring.
Okay.
It is
Based
accurate
on
to
the
90
images of
plus
tools which
percent,
are inspected after
90.26%.
some use. Okay.
Okay.
And
Based on
you
the
are
images of
able to
tools which
learn
are
to
inspected
predict
after
the
some
tool wear
use.
rate,
Okay.
and that learning is
And
90%
you
accurate.
are able to
Use
learn
breaking
to
detection
predict
is
the tool
almost
wear rate,
100%
and that
perfect,
learning is 90%
99.28%.
accurate.
You can predict
Tool
it.
breakage
Now,
detection
if you
is
monitor
almost
the cutting force and
100%
the power
perfect,
consumption, spindle
99.6%.
consumption,
You can
you
predict.
can make out whether
Now,
cutter
if
is
you
broken
monitor the
or
cutting
it is
force
chipped
and the
off.
power consumption, spindle
Right?
consumption,
The cutting edge may be
you
chipped
can
off.
make out whether cutter is
So
broken
based
or
on current
it
and
is
based
chipped
on
off.
vibration and based on cutting
Right?
force,
The cutting edge may be
you
chipped
can
off.
easily predict
So,
that.
based on current and based on
Tool wear
vibration
prediction
and
is
based on
again
cutting force,
99.2%.
you can easily predict
This
that.
is closely matching this.
Tool wear
This is about
prediction is
shape and
again
contour. This is about
99.2%.
statistical feature.
This is closely matching this.
Standard
This
deviation
is
of
about
shape of
shape
the
and
job.
contour. This is about
That
other
is RA value
statistical feature,
obtained.
for example.
Energy
Standard deviation
consumption
obtained
prediction
on the job.
greater than
That is
95%,
RA value obtained on the
etc.
job. Energy consumption prediction
And so
greater
on.
than
Surface roughness
95%,
prediction
etc.
86.5% accurate
Okay.
prediction can be.
And
Now this is
so
just
on.
a
Surface
report
roughness
from
prediction
research.
86.5% accurate prediction can be there. Now this is just a
Now
report from
a very
research.
interesting area where AI/ML is used increasingly
Now
is with the
a very
image-based
interesting
inspection.
area where AI/ML is used increasingly
For
is
example,
with the
TVS.
image-based inspection.
Now this is an excerpt from one of the presentations which
For
you made with
example,
us. On
TVS.
their vehicle line, on their
Now, this is an
scooter
excerpt from
line,
one of the
or
presentations which
motorcycle
they
line,
made with
not your
us.
vehicle.
On their
It is
vehicle line,
aesthetically
on
very
their
important. You
scooter
can't
line
have a
or
dented
motorcycle
product
line,
rolled
I'm
out.
not sure which one.
Right? It
It is
better look good
aesthetically
for
very
somebody to
important.
buy a
You can't
defective
have a
piece.
dented product
So
rolled
what
out.
they have done is on
Correct?
either side of the
It
line, they
better
have
look good
installed two
because
robots
nobody
which
will buy
carry
a
a digital
defective
cam
piece.
and a
So,
light
what
source.
they have done is on either side of the line, they have
So
installed two
they
robots which carry a digital
inspect
cam
the side
and a light
panels
source.
which are aesthetically very
Okay.
sensitive.
So,
The
they
mudguard, how the vehicle looks
inspect
from
the
road to
side
side.
panels which are aesthetically
So
very
any
sensitive,
defective piece,
the
they
mudguard,
take
how the
it to
vehicle
one
looks
side.
from both the sides.
direction.
Okay.
But otherwise,
So
they are
any
making sure that
defective
each
piece,
and every
they
product
take it
will
to one
pass
side and
this
take the
good
corrective
news.
action.
So
But otherwise, they are making
now,
sure that
this
each and
is
every
for the
product which
student
is
where they
passed
are
is good
seeing the
looking.
aesthetics of the
Okay.
surface.
Now this is for the
And for
scooter
seeing
where
the
they are
aesthetic of the surface, we
seeing the
do
aesthetics
eliminate
of the surface.
filling,
Okay.
because for
And
sheet
for
metal
seeing the
panel, the
aesthetic of
best
the
way to
surface,
inspect
maybe
the
you eliminate
aesthetics
it
is to
specially,
illuminate the room with tube
because for
lights,
sheet metal
and you see
panel,
the
the best way
reflection
to
of tube
inspect
light
the
on the,
aesthetics is
let us
to
say, metal disperse plate
illuminate
of
the
the
room with tube
panel.
lights, and you see
Okay.
the
And
reflection
you
of
are
tube
able to
light on
see
the,
any defects
let us say, metal disperse paint of the
very easily.
panel.
Okay.
Okay. And you are able to
Now,
see any
another
defects
is the case study where
very
Bosch has
easily.
done something.
Okay.
They have a full
Now,
inspection pump,
another is the
variety of
case
them.
study where
Okay.
Bosch has
Those
done
were being
something.
inspected
They
manually.
have a fuel inspection pump, variety of them.
They
Okay.
had
Those were
variety
being
of
inspected
models,
manually.
and
Okay.
usually they had lot of problems of some fasteners
They had
missing, some
variety
washers
of
missing,
models,
some nuts
and
being not
usually
being
they had
tightened
lot of problems
properly,
of
and so
some
on.
fasteners missing,
So
some
basically,
washers
what they
missing,
did was
some nuts being
they
not being
have
tightened properly, and so on.
okay.
So basically what they did was
Somebody used to manually
they
inspect
have
each and every piece like this,
not
and
wait
even then there was a
yeah
high probability considering
somebody
that they
used to
have a lot of
manually inspect
models,
each and every piece like
so it can
this,
miss out.
and even then there
Now
was a
what
high
they have done
probability
is they
considering
have
that they
a
have lot
robot
of
which is
models,
carrying a camera
so you
and
can
a
miss
light
out.
source, and
Now what they
each
have
and
done
every
is they
product will
have a
pass through the
robot which is
camera,
carrying a
and
camera and a
they
light
have
source, and each
inspected,
and
they
every
have
product is
created a
passed through the
database based
camera,
on feedback they get.
and they have
So they have teased in the defective
inspected,
looking
they have
product and
created
the
a
okay
database
product
based on feedback
as
based
seen
learning.
from different
So
angles.
they have teased in
Okay.
the defective
So
looking
on the
product
line there
and
is
the
a
okay
robot
product
carrying a camera.
as seen from
It is
different angles.
inspecting each and every
Okay. So on
FIP.
the line, there is a robo
Okay.
carrying a
And it's
camera.
able to make out if
It is
something is wrong
inspecting each
there.
and every FIP. Okay. And it's able to make out if something is wrong in the
Okay.
assembly.
Now what one would say is that if somebody has to do image based
Okay.
inspection,
Now, what one would say is
it
that
is
if
very
somebody has
easy.
to
You take a
do
picture of a defective
image
product,
based
okay product,
inspection,
and the product which is on the
it is
line
very
now,
easy. You
and
take a
you
picture
compare
of a
pixel by
defective product,
pixel the
okay
images.
product, and the product which is
But
on the
then that
line
is
now,
very
and you
sluggish.
compare
You have to
pixel by
exactly
pixel
have
the
the same
images.
condition of illumination,
Okay.
and
But
the
then that
camera
is
has to be
very
seen from the
sluggish.
same
You
angle.
have to exactly have the
Okay,
same
and
condition of illumination,
sometimes the reflection
and
of
the camera
operator
has
side
to
may
be
come.
seen from the same
Sometimes two
angle.
lights may be on, sometimes
Okay.
tube light may be
And
off. So there
sometime
may
the
be some
reflection of operator
variability
side may
depending
come,
on the condition.
sometime tube lights may be on,
Okay,
sometime
it
tube
will
light may be
not be a
off.
robust thing,
So there may be
and
some
will not be
variability
pixel by
depending
pixel.
on the conditions.
Okay,
Okay. So
now
it will
that
not be
was
a
not
robust thing,
practical,
and it will
so they
compare
have used
pixel by pixel.
AIML. So
Okay.
what they have done is
Now
that
that was not
okay
practical.
product and
So they
not
have
okay
used
product.
AIML.
They have
So what
teased
they have
in
done
from
is that
different angles
okay
as seen from
products
different
and not
angles.
okay
Just
products.
like cat and dog, we
They
have
have
identified from
teased
different
in from
angles.
different angles,
Right?
as seen from
So
different
through an
angles.
AIML
Just like
algorithm
cat and
through
dog
neural
being
network,
identified from different
now their
angles,
system has learned
right?
that robo
So
can
through a
just take very
AIML
few pictures from
algorithm
any
through
angle.
neural network, now
Okay.
their
But the
system has
software is
learned
able to make out if
that
the
robo
product is
can just
defective or
take very
okay.
few pictures from any angle.
And to almost
Okay, but the
99%
software is able
accuracy.
to make out if the product is defective or
Right?
okay,
Now this is what can
and to
be
almost
achieved with
99%
AIML.
accuracy,
With of
right?
course teaching of large number
Now
of
this is
data
what
points,
can be
you are
achieved
able
with
to
AIML.
generate
With,
enough
of
references
course, teaching of
so
large number
that
of data
and through
points,
AIML
you are able
you can
to
have a probability
generate
based
enough
judgment,
references
okay, with neural
so that,
model,
and
and
through
you are able
AIML
to predict
you can have a
very
probability
fast
based
whether
judgment,
something is okay or
okay,
not
with
okay.
neural model,
Just like a human
and you
judgment
are
again.
able to
Human
predict
being doesn't look at the product
very
from the same
fast
angle
whether
every time.
something is
Just
okay or
like
not
a
okay.
camera
Just
doesn't
like a
pixel by
human judgment.
pixel
I
the
mean,
images
human
match.
being doesn't look at the
Okay.
product from the
We
same
don't
angle
work
every
like
time,
that.
just like
So
a
the
camera,
robot
so that
also doesn't
pixel
work
by
like that
pixel the
now with
image has to
AI.
match. Okay,
Works
we
more or
don't work
less
like
like
that.
human operator.
So the robo also doesn't work like that now with the IML.
So
It
this is
works more
what
or
I
less like
was
human
saying that
operator.
there are variations in digital image on account of camera angle, intensity of illumination,
So this is what
shadows,
I was saying,
reflections,
that there are variations in digital image on
and it
account of
affects the
camera angle,
productivity and speed if
intensity
you
of
have to
illumination,
compare pixel by
shadows,
pixel.
reflections.
Okay.
Okay,
So reinforcement
and
based
it affects the
learning
productivity and
was
speed if
used,
you have to compare
and
pixel
now
by
the
pixel.
system is intelligent.
Okay,
It has a
so
lot of
reinforcement
database,
based learning
and it
was
can
used,
fairly
and
determine
now the system is
accurately whether
intelligent.
a product
It
is
has a lot
right
of
or wrong.
database, and it can fairly determine accurately whether a product
Now,
is right or wrong.
in case of welding, of course,
Now
what is done here
in case
in
of welding,
digital camera can be
Of course, what is done here
So you can inspect it with
in
heat.
digital camera can be done by infrared
Now,
camera.
just to show you
Okay, so you can
quickly
inspect it with heat.
the video,
Okay,
infrared
now just to
thermography is
show
used
you
to do
quickly
the process control
the video.
as well as
Infrared
inspection
thermography
of
is
the disc.
used to do the process control as well
Now,
as
every
inspection
object is
of
emitting
welding.
certain infrared non-visible light,
Okay.
okay, which
Now,
can be
every
photographed
object
with
is
infrared
emitting
camera in
certain
different colors,
infrared non-visible light,
right?
okay, which can be
And it
photographed with
can
the
convert
infrared
into
camera in
visible
different
for
colors,
us, so that looking at picture,
right?
we or computer can
And
make
it can
out what is the
convert it into
temperature.
visible for us, so that
So
looking
when
at
somebody
picture,
is melting,
we
you
or
can
computer
actually
can make
see the
out what
melt
is the temperature.
temperature and melt penetration.
So when somebody is melting,
Okay.
you can actually see
So
the melt pool
with
temperature
human
and
eye you
melt
can't see
penetration
infrared, so you
depth.
can't inspect.
Okay.
But with
So
infrared camera, you
with
will
human eye
surely
you
be
can't
able
see
to see
infrared,
the
so you
thermal
can't
pattern,
inspect.
and based on
But with
that,
infrared camera,
you are able
you
to
will
inspect
surely
your
able to
heat.
see the thermal pattern,
So all the heat related
and
processes,
based on
maybe
that,
treatment
you are able
or
to
hot
inspect
forging
the
or
heat.
casting
So all the heat
or
related
welding,
processes, say
are you
heat
able to
treatment
inspect
or hot
with heat,
forging or casting
or even
or
when
welding,
refrigeration is
one is
involved,
able to
also
inspect
the
with
reverse
heat.
of heat. Not
Or
only you are
even
able to
where
identify the
refrigeration
hot
is
spots in
involved,
your
of course,
substation or in your
that's the
machines,
reverse of heating.
where the bearings are rubbing, where there is
Not
a
only
flip
you are able
pan,
to
where
identify
there
the
is
hot
a
spots in your
IPO short
substation
circuit.
or in your machines,
Okay.
where the bearings
You
are
can
rubbing,
also
where there's a
see the
friction,
damages in
where there's
structure,
a likely of short circuit.
how the heat
Okay.
flows.
You can also see the damages in structure,
So passive thermography
how the
is
heat
where you
flows.
are depending on the heat emitted by the object,
Okay.
which means that the object
So
is hot
passive
or cold,
thermography
not at room
is
temperature.
where you are depending on the heat emitted by the object,
But where
which
the
means that the object is
object
hot or
is
cold. It is not
now
at
at
room
room
temperature.
temperature, you can do what is
But
called as
where the
active thermography,
object is now
where
at
you
room
heat up
temperature,
the
you can
object
do
or the
what is
assembly,
called as active thermography,
and depending on
where
how
you
heat
heat up
flows, you can
the
determine
object or the
certain
assembly,
errors like cracks,
and
like
depending on
welding
how heat
defects,
flows, you
post
can determine
facto, not
certain
during welding,
errors
after
like
welding.
cracks, like welding defects.
Now this
Post facto means not
infrared
during welding, after welding.
inspection coupled with AEML
Now,
gives you a
this
lot of power
infrared
to
inspection
control
coupled with
the
AIML
processes which are based on heat,
gives you a
like
lot of
welding
power
or like additive manufacturing.
to
The
control
additive
the
manufacturing is nothing
processes
but
which are based on
micro
heat,
welding,
like
linear welding,
welding or
right?
like additive manufacturing. Because additive
So
manufacturing is nothing but
active
micro
and
welding
passive
with
thermography
laser, right?
coupled with AIML,
So,
as in the previous case,
active and passive
you can
thermography
learn the
coupled
okay
with
job, not okay jobs,
AIML, as in the
learn to
previous case,
identify what is okay, what is
you
not
can
okay,
learn
and
the okay
inspect.
jobs, not okay jobs,
So you heat and you are able
learn to
to determine,
identify
let us
what
say,
is
a
okay,
crack
what is
heat,
not okay,
because
and
the heat flow
inspect.
pattern will be affected.
So you
When you
heat
heat, the heat
and
will
you are
not
able to
flow.
determine, let us say, a crack here, because the heat flow
So
pattern
that's
will be
how it is
affected.
done.
When you heat, the heat will not
To
flow through the.
summarize, the challenges in AIML
So that's how it is done.
for learning, you
To
have to make
summarize,
lot of
the
observations.
challenges
So
in
you have to
AIML,
have adequate sample size,
for learning,
because
you
adequate
have to make
learning
lot of
will
observations. So
involve
you
lot
have
of
to have
observations, and
adequate
will take a lot
sample
of time
size,
also, and
because
lot of system
adequate
also.
learning
Okay.
may involve
So this is
lot of
one challenge.
observations, and it may take a
Second
lot of
challenge
time
is
also and lot of patience also.
it
Okay.
is working with
So
the
this is
premise
one
that past
challenge.
empirical data is
Second
still
challenge is,
applicable,
it is
but it
working
may
with the
not no
premise
longer
that
be
past
applicable.
empirical data is still applicable,
For example, I mean,
but
just
it
I
may
have
not no
uttered the
longer
word
be applicable.
astrology so many times. Astrology is based
For
on
example,
planetary positions,
I mean, just I have
okay, and
uttered
the
the word
effect of planets on
techno-astrology so
our
many
lives.
times.
And historically,
Astrology
there is a
is
lot
based
of
on
historical
planetary
data. Based
positions,
on that, the
okay, and
astrologers
the
are able
effect
to
of planets
forecast
on
the
our
route
lives.
what will
And
happen.
historically, there is a lot of empirical data.
But that is
Based on
assuming
that,
that you are
those
on the Earth.
astrologers are
Suppose
able
you
to
are
forecast
traveling in
about
space,
what will happen
then will
for you.
astrology will still
Correct?
applicable for you.
But that is assuming that you are on the Earth. Suppose you
So
are traveling in space,
what I mean to
then will
say,
astrology
the
be still
changes,
applicable for
the
you?
rate of
That's the
changes
problem.
have increased in last century
So
enormously.
what I
So
mean to
what
say,
was
and the
applicable,
changes,
let
the
us
rate
say
of changes
17th
have
century,
increased in
18th
last
century,
century
right from 5000 year
enormously.
BC
So
to
what was
1500
applicable, let us say in
AD,
17th century,
the
18th
life was pretty
century,
much the
right from
same.
5000 year
But
BC
there have been
to
many changes in
1500
technology, the way
AD,
of life, everything.
the life was pretty much the
So
same.
whether the past
But
empirical
there
data
have
is
been many
still valid
changes in
is a big
technology, in the
question.
way of life, and everything.
Correct. So
So
AIML
whether the
also
past
has the same
empirical data
experience.
is still valid
Whatever you have
is a
learned
big
under
question mark.
what circumstances you have learned,
So AIML
whether
also has
in
the same
future the
handicap.
circumstances are going to be
Whatever you
still
have
fall
learned,
will
under
be
what
affected.
circumstances you have learned,
If the
whether
technology is going
in
to be
future the
defined properly,
circumstances are
the
going to be
behavior
same or
patterns
they will
also
be
will be
different.
same. Correct.
If
So
the
there is a
technology
factor
is
of
going to be
changing level
different,
of toxic
probably
that
the
gets
behavior
refined.
pattern may
The
also be
previous
different.
data of PID may not work.
The way the controller, CNC controller works, if that is gets refined, your previous data of PID may not work
So many things
because the
can
way
change.
you are having the
Whether
algorithm
the
itself
past
has changed.
empirical data is still
Correct?
applicable in
So
future is a question
many
mark.
things can change. Whether the
And
past
if you have
empirical data
disruptive
is still
technology,
applicable
breakthrough
in future
improvements,
is a question mark.
may happen precisely that way.
And
That
if
whatever
you
were
have
your
disruptive
assumptions earlier
technology,
may fall
breakthrough
apart.
improvements, it may happen
Right?
precisely that
So
way.
it may or may
That
not
whatever
continue
were
to
your
work
assumptions
as
earlier may go out
effectively
of the
as it
window.
was working earlier. This is the
Right?
thing.
So it
And
may
there
or
is
may
always
not
a
continue
confusion
to work
factor.
as
Suppose you are
effectively as it
inspecting
was
through
working earlier.
AI.
This is a
There is a
challenge.
finite
And
probability
there is
that you may
always a
accept
confusion
a
factor.
wrong
Suppose
part
you are
or you may
inspecting
reject the right
through
part.
AIML.
Now that
There
is
is a
called as
finite
confusion
probability
matrix.
that you may accept a wrong
So there
part
is
or you
still
may
a
reject the right part.
probability because all
Now
these
that is
neural
called as
things
confusion
are
matrix.
probability based.
So there is
Output
still
is
a
never 1. It
probability
is
because all these
0.98,
neural things
0.99,
are
0.9.
probability
Somewhere
based.
you are taking some approximation.
The output is
So
never
the
one.
balance
It
is the
is
confusion factor.
0.98,
There will be some
0.99, 0.9.
error in judgment.
Somewhere you are taking some
The error
approximation.
in judgment
So the
is the
balance is the
confusion
confusion
factor.
factor
In
where there will be
AIML,
some
there is a finite
error in
probability
judgment.
of error in judgment.
The error in
It should
judgment
be reasonably low,
is the
such that
confusion
there is
factor.
tolerance.
In
But to
AIML,
be
there is a
reasonably
finite
high.
probability of error in judgment.
Otherwise, there is a tolerance. We
It
are
should be
assuming
reasonably
that
low,
nothing
just
is
like
perfect,
engineering
nothing can be
tolerance
perfect.
has to be
Therefore, we have
reasonably
tolerance
tight.
in engineering front.
But
So something
otherwise,
like
there is a
that
tolerance.
in
We are
AIML
assuming
as well.
that nothing is perfect, nothing
Then
can be perfect. Therefore, we
it is
have tolerances in
applicable
engineering
generally
front.
where
So
statistics is
something like that
applicable.
in AIML as well.
AIML is generally
Correct?
not useful for one-off
It is
jobs.
applicable generally
If
where
you are making
statistics is
just one-off
applicable.
very big boiler,
AIML is
then you can't
generally
be
not
applying
useful
AIML because
for
you don't
one-off
have
jobs.
the
If
data in
you are
similar
making just
context
one-off very big boiler,
earlier available.
no, you can't be applying
Everything is
AIML
depend
because you
on
don't
the
have
particular product
the data in
and
similar
speed
context
feeds and whatever welding you
earlier
are going to
available.
do, whatever engineering
Everything is different about this
assumptions are
particular
there,
product,
everything would be different.
and speed
So
feeds and
generally
whatever
not
welding you
found
are going
suitable
to do,
for
whatever
one-off jobs.
engineering
There you have to go by
assumptions are
engineering
there, everything could be
fundamentals and
different.
results.
So it's generally not
But in
found
mass
suitable
production
for
and batch
one-off jobs.
production,
There you have
yes,
to go by
one could go
engineering
for
fundamentals
AIML
and rigorous testing.
reasonably
But in
well
mass production and
accurately
batch production,
and with
yes,
fair
one
amount of
could go for
reliability.
AIML reasonably,
Now
uh,
AIML tends to
well
create an
accurately,
impression that bigger engineering
with
pieces
fair
can be
amount of
bypassed.
reliability.
This is wrong again.
Now,
It
AIML
cannot be
tends to
bypassed
create an
here because
impression
you
that
have to
rigor
send
of
two
engineering
rigors.
basics can be bypassed, which is wrong again.
Good. With this,
It cannot be
I end my
bypassed. Where
talk.
required, you
Thanks
have
for
to
your
still do
attention.
rigor in engineering. Okay.
And over to
Good.
the
With
coordinator,
this,
sir.
I end my talk. Thanks for your attention.
I
And
hope
over
the
to the
talk was
coordinator, sir.
understood and
I
useful
hope
and
Yes,
the
sir.
talk
Thank you,
was
sir. Thank
understood,
you, Sri Avinash Khare, sir, for your
yes, Dr. Vikram.
useful, and people
informative
found it
session
interesting.
on overview of AI and ML for mechanical
Yes, Dr.
engineering
Vikram.
faculty.
So, ladies and gentlemen, bye bye and good luck from me. And see you sometime in some other
So,
event.
ladies and gentlemen, bye
Hello,
bye and good
sir.
luck from me.
Hello, sir.
And see you sometime in some other event.
Hello.
Hello, sir.
Hello.
Hello, sir. Hello.
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 Hello. Hello,
Dr.
sir.
Vikram sir, you are not audible.
Hello.
Sorry.
Dr. Vikram, sir,
Sir.
you are not audible.
Am I audible, sir? Avinash Khare, sir.
Hello.
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 Yeah.
Our voice is not audible to you, sir.
Yeah. Your voice is not audible.
Yeah,
I was audible.
your voice is audible, but our
Yeah,
voice is not
your
audible.
voice is not audible. But anyway, my voice was audible.
I have finished.
And two questions, two partner have raised some questions, sir.
Anyway, I have finished. So
Yeah.
thanks a lot.
Yeah. Please ask me.
Yeah.
You can ask me, sir. Question.
Read out the question.
Yeah. Please ask the question.
Yes, sir. Sir, one participant asked you about the which software are used for the deep learning. One participant requested which software are used for the deep learning. Deep learning.
Deep learning, there are several software nowadays, but people have a tendency to use this one.
Deep learning, there are several software
First
nowadays,
slide I have
but people have a tendency to
Arduino
use
or
this one. Commonly
Arduino is
used
being
this thing.
used,
In my first slide, I have
And one more
Arduino
and
or
Python
something
also.
like that. Yeah.
Python also is being used.
Arduino is being used,
So one more question.
and
Sir.
people use Python also.
Kamal
Python also is
Kamal
being used.
Kamal is asking. In AML, some data from the past experience should be given
Yeah.
for comparing without AML. He is asking. It is available in chat box. Sir.
Yeah.
I'm not understood.
I have not understood the question.
How does learning occur in neural network? What is the feedback and feed forward control? That is a question asked by Kamal Jyoti Talukdas. How does learning occur in neural network? What is feedback and feed forward control?
Hello, sir. Avinash sir.
Yeah. Yes, please.
Yeah. Yes,
Can
please.
you type the question otherwise in chat box?
Sir, it is available.
See the chat box.
Can you type the question otherwise in chat box?
Sir, available in chat box.
See
Sir,
the chat box.
Oh, yeah.
sir available in chat box.
It's available in chat box. AI/ML data from past experience should be
Hello.
used for
Yeah.
comparing without AI/ML. No,
It's
without
available
AI/ML also
in
it is
AIML. The data from past experience should be
only thing
given for
is just
comparing
AI/ML you
without
have
AML.
technically
No, without
calculating the
AIML also you
probability.
can use the past experience
So the
data.
way you do the
Only
learning
thing
is
is, yes, in AIML you
otherwise
are
it's not that
statistically
the past data is
calculating the
not used in
probability
other
and weightage
platforms.
factors.
Now
So the
AI,
way you do the
you
learning
also
is
can use
different.
the past
Otherwise, it is
and
not
feedback
that the
control
past
is
data is
also
not
used.
used in other way of
Feedback
learning.
control is used.
Without
Then
AIML
the
also you
past
can
data.
use the past experience.
But
Like
here,
feedback control is always
we
used
are tuning
so
up
in
based on
flow
the
control,
past
closed
experience
loop
in a
control.
certain way
We
that
are
we are
using past
improving the
data
weightage
always.
factor or the
But
probability
here
factor
we are
for
tuning up
coming
based
at the
on the
correct
past
place.
experience in a certain way that we are improving the weightage factors or the
Can you
probability
please show the
factor
challenges
for
slide once?
coming at the correct judgment.
Last slide. What I would suggest
Can you
because
please show the challenges
majority
slide
of
once?
students.
Last slide.
Hello. Okay, sir. Okay.
What I would suggest,
Yeah,
Vikram
I will
sir,
share you.
I'll
I will
share you
give
the
you
complete
the
presentation.
presentation. You can share it.
Okay.
Hello. Yeah,
What
I
is
will
feedback
share you.
and feed
I will give
forward
you the
control?
presentation. You can give it.
Feedback is a control where you give a step command and you learn
What
the
is feedback
mechanical
and feed
response
forward control?
and based on
Feedback
that you
is a
improve the
control
PID.
where you
That
give
is
a step
feedback.
command and you
And in
learn
feed
the
forward
mechanical
control,
response of the
you
system,
predict the
and
behavior
based
of
on that you
mechanical
tune the
system
PID.
by your
That
prior
is
knowledge
feedback. And in
and you
feed
modulate the
forward
command
control,
itself.
you predict
You
the
don't
behavior
adjust the
of
PID.
mechanical
You
system
modulate the
by
command
your
itself.
prior
Instead of giving
knowledge,
a step command,
and you modulate
maybe
the
you
command
give a
itself.
command itself which is
You
operating.
don't adjust the PID.
Modulate the
You
mechanical
modulate the
system
command
down.
itself. Instead of giving a step command, maybe you give a command itself which is oscillating,
Video I will not share
so that the
because it
mechanical
is
system
YouTube
does not
video.
oscillate.
So there are complex issues. But they are there on YouTube, you can find them.
Video I may not
Slides
share
I will
because it is
share.
YouTube video, so there are
Other
complex
slides I will
issues.
share.
But they are there on YouTube. You can find them very easily. But slides I will share
You
you.
need a practical example of vibration
All the slides I can
analysis
share.
of a machine using AI/ML.
You need a practical example of vibration
That's
analysis
some case study
of a machine
from
using
IIT Kanpur.
AIML.
But I have to ask Professor Yusuf Jalil. Of course, they did
That's some
present in
case
one of
study
our seminars.
from IIT Kanpur,
I can
but
send
I'll
you
have
on
to
this one.
ask
You can
Professor
write a
Ishwar
mail
Jalil.
separately
Of
actually.
course, they did present in one of our seminars.
Sushmita,
I can send you
you
some
can
info.
write
You
me
can
an
write me a
email.
mail separately. I will share
But
you.
only question is that I'm
Sushmita,
not available for
Sushmita
a
ji,
month.
you can
Going to
write me
UK.
an email.
I'll be able to respond
But
after a month.
only caution is that I am not
I hope that
available
helps.
for a month. I'm going to UK, so I'll be able to
How
respond
to
after a
decide
month.
the sample size?
I hope
Well,
that is
it
okay.
depends on your prior learning. If you
How
have
to
some
decide the
prior
sample
learning, then the
size?
sample size comes down.
Well, it depends
Mostly
on
what
your
people
prior
do,
learning.
particularly in
If
the
you have
urban
some
system
prior
or
learning,
village,
then the sample size comes down.
suppose you are identifying,
Mostly
let us
what
say,
people do,
car,
particularly in the
various
algorithms
models
which
of
are
car,
for identification.
right? And now you have added
Suppose you
some
are
very new
identifying,
models,
let us say,
but you already
cars,
had some
various
100
models of
models
a
which
car,
were taught.
right?
Right?
And
Now
now
you
you
have
have
to have
added
a
some
small
10
sample
new
size
models,
to
but you
incrementally push the
already had
response.
some 100 models which were taught
But
in.
otherwise, if you have to do from
Now
zero,
you have to have a
it
small
takes
sample size to incrementally teach the new models.
This.
But otherwise, if you have to do from
email
zero,
ID will not
sample
be.
size is much more.
Okay, I will type my email ID. Please send me a mail.
This Susmita ji, your email ID will not be. Okay, I will type my email ID. Please send me a mail.
I have shared my email ID to all of you. Anybody has any query, please write to me. The only thing is,
I have
I'm
shared
not
my email
available
ID
until
to all of you. Anybody has any query, please write to me. The only thing is, I am not available. I am going abroad tomorrow.
Recording of the
So,
session, you can ask.
after 1 month, I will be able to respond because I am not around.
So please write me a mail.
Recording of the session, you can
Possible,
ask
I will
to sir.
respond, otherwise when I come back. After a month, I will do it.
So please write me a mail. I will, if possible, I will respond. Otherwise, when I come back to office
Right.
after a month, I will be able to respond. I hope
Right,
that
sir?
is clear.
Ladies and gentlemen, I
Right.
leave now.
Right, sir?
You want to ask?
Ladies and
Thank
gentlemen,
you,
I
Sri Avinash
Mr.
Khare
Leave
sir,
now.
for your informative session on
Amal Jyoti, you want to ask something?
applications of AI and ML for mechanical
Right,
engineering.
right.
Now, I would like to
PPT
summarize.
Today itself, I mailed it to Dr.
I would
Vikram.
like to summarize the session of Mr.
PPT
Avinash Khare sir.
mailed to Vikram.
He has given us the overview of AI and ML and DL.
Sorry, your voice is not audible to me, so it is one-way interaction.
Bye-bye. Hope to see you sometime.
Okay, thank you. You have been a patient
Thank you very
audience.
much.
Good luck.
I would
Bye
like
bye.
to give
Hope to see
the
you
summary
sometime
of
some other
the session
time.
given by Avinash Khare
All the
sir.
best.
You are delivering us the meaning of AI, ML and DL and their interconnectivity at the starting of his session. And he was talking about neural networks and what ML does. And later on he was talking about emulating neural networks for the application of mechanical engineering applications. And he was talking about various applications in the area of mechanical domain. And namely, I just quote some of the applications: adaptive auto tuning of servo controls, where the effect of cutting forces can be corrected using ML, machine learning. And also, he was mentioning one of the important point at feedback control systems. In the normal system, we use feedback control system, whereas by using ML, we can give feedback forward systems. That was the point he was highlighting. And later he was mentioning about inaccuracies in large machine and how to take care of those large inaccuracies using ML applications. And he used a right word there, AI and ML is a shortcut of solving engineering problems. And he was mentioning about one of the important applications of AI and ML in dynamic precision of machine tool, adaptive machining, AI-aided digital imaging based inspection for vehicle inspections when it was moving on the conveyor belts. And these were the main points he has highlighted. And also at last, he mentioned about some of the challenges using AI and ML. So with this, we have the participant got benefited a lot through his session. So thank you, sir, for your valuable inputs. So I hope the participants got benefited out of the session. So we conclude the session one now. Already the attendance link posted in the group. I request all the participants to give their attendance today itself immediately. And the second session.